Hello everyone, welcome to my channel. This is 𝐕𝐢𝐻𝐻𝐿. And in today's video, we are going to deploy a digital banking platform on Amazon EKS. And it's a full stack microservice based application with around 30 plus services running on Amazon EKS, where customers can register and open bank accounts, deposit money, check their balance, and send money to other people and view their transactions history. And it's similar to what you would see with online banking or apps like PayPal, guys. Okay, so now let me sign into this account, and after that let me show you all the services which are running on EKS cluster. So initially we need to create an account, and let me provide full name as Vijay and vijay@gmail.com, and the password is vijay@123, guys. Okay, so initially we need to create an account. So here you can see account has been created successfully, guys. Okay, so this is the banking platform. So I'll explain you in detail within next couple of minutes. Before that, let me show you all the services which are running on EKS cluster for this banking platform. So let me open this shell and let me run this command kubectl get ns. It is going to display all the namespaces inside our EKS cluster. And let me show you all the pods inside this banking namespace kubectl get pods -n banking, and it is going to display all the pods inside this banking namespace. And here you can see these are all the pods required to run this banking application, guys. Okay, now let me open this, and here you can see we have nearly 30 plus services which are running on EKS cluster for this banking platform. So few of the services like account service, admin service, analytics service, API gateway, audit service, authorization service, beneficiary service, card service, currency service, customer service, document service, email service, EMI service, fixed deposit service. Okay, so like this, we have nearly 33 services which are running on banking platform, guys. Okay, so now let me open architecture. So in this video, our main focus of this project isn't just the application itself. It's the entire DevOps lifecycle. I have set up everything end to end, like infrastructure creation with Terraform on AWS and containerization with Docker, deployment on Amazon EKS through Helm charts and GitOps for continuous delivery with ArgoCD, and continuous integration with GitHub Actions, image security scanning with Trivy, monitoring with Prometheus and Grafana, log aggregation with Logi, distributed tracing with Tempo and OpenTelemetry, backups and disaster recovery with Velero, guys. Okay, and finally HTTPS with Cert Manager and Let's Encrypt. And under the hood, all the 30 services communicate over gRPC, and also they use Kafka for event streaming and Redis for caching and PostgreSQL with a proper double entry ledger, guys. Okay, and finally entire application is live on my custom domain, which is vijay.githuri.in, which is reachable over HTTPS with a real browser trusted certificates that auto renews for every 75 days, guys. Okay, so now let me show you all the dashboards of this application like ArgoCD, Prometheus, Grafana, Alert Manager, and our application and everything. Firstly, let me open our application, and here you can see our application we are currently accessing with my domain, which is vijay.githuri.in with HTTPS, case. Okay, and here you can see connection is secure. So now let me open this ArgoCD, and here you can see we are accessing ArgoCD with my domain slash ArgoCD. And we are going to secure this ArgoCD also, guys, with HTTPS. Here you can see HTTPS colon slash slash vijay.githuri.in slash ArgoCD. And here you can see connection is secure. So basically ArgoCD deploys everything from Git automatically, like banking application, runs all 30 plus services, and other apps run monitoring, TLS and backups, and all keep in sync with self-heal, guys. Okay, so here you can see we have multiple applications like banking platform, set manager, issuer, cluster storage, queue, Prometheus stack, Loki stack, hotel collector, observability extras, metric server, platform root, and Velero, OpenTelemetry. Everything we are deploying using ArgoCD applications, guys. Okay, and if you want to see all the services which are running on banking platform, so you can directly open this, and here you can see this is the account service, admin service, analytics service, API gateway, audit service, auth service. Everything we are deploying using ArgoCD, guys. Okay, and we are deploying this using Helm chat. Okay, Helm chat is available inside the GitHub repository, guys. Okay, so in next few minutes I will explain you in detail about the Helm charts and how it is going to deploy and everything. Okay, now let me select here applications. So if you want to list all the ArgoCD applications from CLI, you can directly run this command, guys. Okay, so let me open this, and kubectl get applications -n ArgoCD. Okay. Or else instead of applications, you can directly select app also, guys. Okay, it is going to display everything. So banking platform, set manager, issuer, cluster storage, queue, Prometheus stack, Loki stack, metric server, observability extras, hotel collector, platform route, tempo, velero, everything we are going to deploy using Argo CD itself, guys. Okay. So now let me open this and let me open Prometheus. Okay, so here you can see we are going to access Prometheus with my domain name, which is vijay.in/Prometheus, guys. Okay, and here you can see this is HTTPS, which is connection is secure. And if I select here, so here you can see connection is secure, guys. Okay, so here basically Prometheus grabs and stores metrics from every service and the cluster, and everything you will see in Grafana is powered by the data collected here, guys. Okay, and I can run few of the queries here from live. So you can find all the queries inside the GitHub repository. So let me open the GitHub repository and let me close this architecture diagram. And you can directly open these docs. Inside docs, you need to jump onto AWS, and here we need to open observability. And let me come down. Okay. And here you can see these are all the Prometheus queries case. Okay. So if you want to see all the targets are up or not, you can directly run up, or else if you want to see only banking application targets, you can directly run this command, guys. Okay. For now, let me select here up. It is going to show us all the targets, and here you can see it is going to show all the targets, and everything is one, meaning it is working. And now if you want to see only for banking application, meaning banking namespace, you can directly execute this command up namespace equal to banking. So here you can see everything is up, guys. Okay, so now let me open this. And if you want to see total HTTP request rate per service, you can directly run this query. Let me copy this and let me open Prometheus and let me paste it here and execute. Okay. So here you can see for notification service, we have nearly 2561, and for loan service, we have nearly 2560, and for fixed deposit service, we have nearly 2561. Okay. So these are all the requests for every service case. Okay. Here you can see transaction, beneficiary, admin service, profile service, investment service, payment service, fraud service, wallet service, and all these services are running on EKS cluster, guys. Okay, and let's go to in deep dive in next few minutes about all these queries, guys. Okay, so because this is just an intro, so now let me open Grafana, and here you can see this is Grafana, and let me come out from this. Okay, and here you can see Grafana we are currently accessing with my domain, which is vijay.in/Grafana, and currently we are accessing with HTTPS connection, guys. Okay, and here you can see connection is secure for Grafana also. So now let me open this dashboards. So basically, Grafana takes metrics from Prometheus and turns into the visible dashboards, guys. Okay, and I will have built dashboards one for every service, so I can see its running pods, request rates, latency, CPU, memory, and live logs all in one place, guys. Okay, for every service. So now let me show you all the dashboards. So if you want to see all the dashboards, you can directly open this, which is banking service details, or else if you want to see only banking platform services, so here you can see this. Okay, but if you want to see individual dashboard, so you need to directly open this banking services detail per service. And here you can see this is the account service details, guys. Okay, for account service only one pod is running. So if you want to check this, you can directly come here, and here kubectl get pods -n banking and grep account. Okay, account. Okay, let me remove this account service. Okay, so it needs to display only single pod, guys. Okay, so here you can see we have single pod for account service. So here you can see similarly it is showing running pod is one, request rate P95 latency, and the request rate by status P95, P50, P95, P99 latency, CPU usage per pod, memory usage. You can see everything, guys. Also you can see live logs from Loki also, guys. Okay, so these are all the live logs which is generating by Loki, guys. Okay, only for this account service. So similarly we have 30 dashboards for every service. Okay, so this is the account service dashboard, admin service, analytics service, API gateway, audit service, auth service, beneficiary service, EMI service. Okay, so here you can see we have every service dashboard. For example, let me open email service, and for email service here you can see only single pod is running for email service, and similarly you can see request rate P95 and request rate by status and latency, CPU usage per pod, memory working set per pod. You can see everything in detail, and also live local logs, guys. Okay, for every service you can see everything. For example, if you want to, currently here it is displaying only single pod, right? And if you want to cross check this, so this is the email service, right? So let me come here, and here let me provide email hyphen service. Okay, so it is going to display all the pods inside this banking namespace for email service. So for email service we have only single pod. Okay, so here you can see it is showing single pod. Okay, it is going to display everything in detail, guys. Okay, for every service. For example, if you want to open customer service, and here you can see for customer service also it is going to show us everything in live, including live local logs, guys. Okay, so this application is not a real-time application. I just created this application only for learning purpose, but this application will work similarly like a real-time application, guys. Okay, so finally let me open here alert manager. So alert manager works with Prometheus to handle alerts. So when a metric crosses its threshold, like if a service goes down or high memory, it fires an alert here, guys. Okay, and it can directly notify us by email or Slack, guys. Okay, so now let me show you all the services which are running on EKS cluster. Let me open this shell, and let me do initially kubectl get ns. And here you can see we have all these namespaces. Before that, let me show you all the Helm charts, guys. Okay, currently we have only two different Helm charts. One is Traefik and one is ArgoCD. Okay, so here you can see this is ArgoCD and this is Traefik. So now let me show you all the pods inside banking. I think I have already shown you this, right? And here you can see these are all the 30 plus services running inside this banking platform. Now, if you want to see all the applications like ArgoCD applications, you can directly run this command kubectl get app-n ArgoCD. It is going to show us all the applications, guys. Okay, and here you can see these are all the applications. If you want to see in CLI, so this is the command. You can directly hit kubectl get applications or else app. Anything is not no problem. But we created on ArgoCD namespace. Okay, so now these are all the banking namespace pods, right? So now if you want to check for observability, you can directly run this command kubectl get ns kubectl get pods hyphen n observability. Okay, let me copy this and let me paste it here. Okay, so inside this observability namespace, we are running Prometheus, Grafana, Alert Manager, Loki, Tempo, and OpenTelemetry, guys. Okay, so here you can see everything is up and running. So now, if you want to check ArgoCD pods, kubectl get pods hyphen n ArgoCD, and here you can see this is the ArgoCD namespace. And these are all the pods which are running on ArgoCD namespace, guys. Okay, so similarly, if you want to check for cert manager, so let me copy this. Okay, so kubectl get pods hyphen n set manager, and it is going to display all the pods, guys. Okay, so here you can see these are the set manager pods, and this is the CA injector, and this is the webhook, guys. Okay, so similarly, if you want to check for traffic, you can directly run this. Okay, it is going to display traffic pods, and here you can see both the pods are running for traffic. And finally, if you want to check for Velero, so basically this is for backup and disaster recovery, guys. Okay, so here you can see these are the pods which are running for Velero, guys. Okay, finally, if you want to check a horizontal pod autoscalers for our banking application, you can directly run this command kubectl get HPA hyphen n banking. Okay, and here you can see these are all the horizontal pod autoscalers for all the services, guys. Okay, so similarly, if you want to see all the services for banking platform, you can directly do kubectl get services, guys. Okay, And here you can see all the services are running inside this EKS cluster case. Okay. So finally, everything starts with Terraform, right? So instead of clicking around AWS console, I defined the entire infrastructure as a code with single command. It is going to create entire AWS infrastructure case. Okay, like networking, EKS cluster, storage, container registry with single command, and also we can tear down using single Terraform destroy command, guys. Okay, so now let's destroy this entire infrastructure and let's start this entire project from scratch. So before destroying this AWS infrastructure, let me show you the current state by running this command. Before that, let me check. Okay, so we are inside the Terraform directory, environments in dev. Okay, so now let me run this command Terraform state list. It is going to display all the created resources using Terraform. And if you want to see all the Terraform scripts, so you can directly select your banking application, and here you can directly jump onto Terraform, and here you can see modules. And here these are all the modules, guys. Okay, ECR, EKS, IAM, Route 53, S3, Velero, VPC, guys. Okay, so we are going to create this everything. Let me come here. Okay, so here you can see these are all the resources it has created, guys. Okay, and the best part is, let me open here VPC. Okay, and here you can see this is the banking VPC, and let me select here resource map and let me keep like this. Okay, so basically we created two different subnets inside this banking VPC. One is public VPC, sorry, public subnet, and the second one is public subnet in three different zones case. Okay, so here you can see US Central 1A, US Central 1B, US Central 1C. Okay, in every zone we have public and as well as private subnets case. Okay, so here you can see in US East 1A we have public subnet and private subnet. In US East 1B we have public and private. In US East 1C we have public and private, and all the public subnets are associated with the public route table, and all the private subnets are associated with the private route table, and this private route table is associated with NAT gateway, and this public route table is associated with internet gateway, guys. Okay, and we are going to deploy our EKS cluster on private nodes, guys. Okay, and if you want to see this EKS cluster, so here you can see this is the EKS cluster, and let me come out from this, and here you can see banking dev. So this is the EKS cluster, and compute we have nearly 4 nodes up and running from last 5 hours, guys. Okay, so now let me open this ECR. So basically we are storing all the images on this single ECR repository, guys. Okay, let me select your repositories. So this is the single ECR repository banking platform. Inside this banking platform ECR repository, we are storing all the images, guys. Okay, and for building and pushing these images we are using GitHub Actions. So let me select here Actions, and here let me open update ci.ml pipeline. So here you can see it is going to build nearly 32 services Docker images. After building this Docker images, it is going to update all the image tags on Helm values.ml file, and next ArgoCD will come to picture, and it is going to deploy these services to the EKS cluster, guys. Okay, so this is the flow. In future I am going to explain everything in detail, guys. Okay, so this is about the GitHub Actions pipeline. So now let's destroy this entire AWS infrastructure. So basically this destroy will take around 20 minutes to destroy all these resources, guys. Okay, because only EKS cluster will take around 15 minutes to destroy, guys. Okay, so you can directly come here and let me do ls, and you can directly run this command terraform destroy hyphen hyphen auto hyphen approve, guys. Okay, let me hit enter. So now it will destroy all the resources using our Terraform scripts, guys. Okay, because we created this entire AWS infrastructure using Terraform itself. Okay, so once it's destroyed, let's start this entire project from scratch, guys. Okay, so let's wait for some time. So now entire AWS infrastructure has been destroyed successfully. So now let's start deploying this banking application from scratch. So you can follow the docs which are available inside docs/AWS inside the repository. So let me come here. So this is the banking application EKS repository. And here you can directly jump onto docs, and here open AWS, and these are all the phases, guys. Okay, nearly we have 8 phases. So right now we are on first phase, which is terraform hyphen infra.md. Okay, So before that, let me show you all the services. So here you can see we don't have even single ECR repository. If I refresh this, so here you can see we don't have even single ECR repository, and we don't have even single EKS cluster, and we don't have ECR, sorry, Route 53 hosted zone, and we don't have VPC guys. Okay, so we have only test VPC and the default VPC guys. Okay, so now let me open this phase one. So now in phase one we are going to provision all our AWS infrastructure using Terraform. So basically Terraform is an open source infrastructure as a code tool which is developed by HashiCorp. So instead of logging into AWS console and clicking through hundreds of screens to create networking, Kubernetes cluster, storage, we describe everything we want in a code. Then the single command Terraform takes to AWS and builds it all for us, guys. Okay, exactly the same way every single time, guys. Okay, we are choosing Terraform because it's repeatability, version controlled, and reviewable. And the entire AWS infrastructure lives in Git alongside with the application. Anyone can see exactly what's deployed and when we are done. So one command tears all down cleanly with nothing left behind to keep cost, guys. Okay. So with Terraform, we are going to create a VPC, public and private subnets across three availability zones for a high availability, and an internet gateway and NAT gateway. So private servers can reach to the internet for updates without being directly exposed, and an EKS cluster, managed node pool, and a private ECR repository, and an S3 bucket, finally IAM roles and IRSC guys. Okay. So now let's create AWS infrastructure using Terraform. But before that, we need to manually create an S3 bucket to store Terraform state file. And next, we need to update that S3 bucket name on backend.tfs. Okay. So already I have created an S3 bucket. So I'm going to use that same S3 bucket to store Terraform state file. So if you want to create an S3 bucket, so here you can directly run this command, guys. Okay. So using this command, you can directly create an S3 bucket, or else if you want to create it manually, so you can create manually also, guys. Okay. So here you can see this is my S3 bucket, banking platform TF state. So I'm going to use this same bucket, but let me delete all the resources inside this bucket. Okay. Delete. So now I deleted my old state. So let me close this, and here you can see inside my banking platform TF state bucket we don't have a single object, guys. Okay, so you need to update this, you need to create an S3 bucket, and next you need to update this bucket name on backend.tf, guys. Okay, so you can directly find this backend.tf here itself. Let me keep it like this. Okay, and let me open here Terraform, and let me jump on to environments and dev, and here backend.tf. Okay, so here you need to update your bucket name. Yes, okay, so you can create S3 bucket with any of the name, but you need to update this bucket name, guys. Okay, because we are going to store Terraform state file inside this S3 bucket, guys. Okay, so let me clear the screen and ls and cat backend.tf, and here you can see so same bucket I'm going to use. And now let me open this documentation and let me come down. Okay. So you need to jump on to Terraform environments and dev, and you need to run this command which is Terraform init. So first let me enter into this directory. I think already I have inside the directory. Okay. So here you can say I'm inside the directory Terraform environments and dev. Now let me run this command Terraform init. So basically Terraform init command connects to our S3 backend and downloads everything it needs, guys. Okay. Next, we need to run Terraform plan. So basically, Terraform plan shows us the preview of every resources Terraform is going to create before it touches anything, guys. Okay, and Terraform plan is one of the important command, guys. Okay, let me run this command Terraform plan. So now it is going to show all the resources what it is going to create. Okay, so here you can see it is going to create nearly 64 resources it is telling us. Okay, it includes everything like IAM roles, policies, and EKS cluster, ECR repository, S3 bucket, ECR repositories, and everything, guys. Okay, it is going to create everything. Now, if you want to check this Terraform code is valid or not, you can directly run this command, which is Terraform validate. So it is going to check whether our Terraform code is valid or not. So here you can see success, the configuration is valid. And if you want to keep the code in a proper format, you can directly run this command, which is terraform fmt. So this command is going to keep your code in a proper format. Now finally, important command is terraform apply hyphen hyphen. Okay, so instead of running this, let me come here, and here you can see I'm going to apply individual module, guys. Okay, so let me open modules. Inside this we have multiple modules. So in this video, I'm not going to apply Velero module and as well as EC2 module. Okay, I think EC2 we don't have. Okay, that's great. So I'm not going to apply Velero module. So that is the reason why I'm going to uh, run commands like this. Okay, terraform apply hyphen target is equal to module.vpc module.iam module.eks. Okay, so if you want to create including Velero, you can directly create using single command, which is terraform apply hyphen hyphen auto hyphen a progress. Okay, but expert this Velero, I'm going to create all the modules, right? So that is the reason why I'm applying an individual module, guys. Okay, so now let me copy this and let me paste it here. Okay, so basically this terraform plan creates everything on AWS, guys. Okay, like it is going to create EKS cluster, ECR repository, S3 bucket, time roles, route 53 hosted zone, everything, guys. Okay, and it will take around 15 to 20 minutes to create all these resources, guys. Okay, because only EKS cluster will take more time, guys. Okay, so I just forgot it to tell you one thing. Let me cancel this. Okay. So before running Terraform init, Terraform plan or Terraform apply, you need to run this command, guys. Okay. So I just forgot it to tell you this. Let me open IAM. So you need to create IAM access keys and secret keys, guys. Okay. So let me select here users. So this is my user, which is Vijay Girturi. You need to jump onto security credentials, and here you need to create IAM access key and secret key. So here you need to select create. Let me go back, and here you need to let me come down. You need to select create access key, and here you need to select type as CLI and next. Okay, you need to check mark this and next. So when you select create access key, it is going to provide us access key and as a secret key, guys. Okay, next you need to copy these keys somewhere, and you need to connect to your AWS account, guys. Okay, you need to run this command, which is AWS configure, and here you need to provide your access key. So this will be your access key, and next you need to provide your secret key, and this will be your secret key. Okay, so this will be your secret key, and next here you need to provide your region, which is US-East-1, guys. Okay, so because I'm going to deploy this on US East 1 region, let me come here, and here you can see North Virginia, which is US East 1, guys. Okay, so already I configured my credential site, so that is the reason why I'm not going to provide this, guys. Okay, now let me do AWS S3 LS. It needs to show all the S3 buckets, guys. Okay, so here you can see we have three buckets. One is banking platform TF state and banking Velero backups and SagaMaker AP South one, guys. Okay, so let me delete this bucket first. Okay, let me jump on to S3 and buckets, and here it is showing only. Okay, and let me delete this bucket, empty bucket. Okay, and empty. Now let me delete this bucket, delete bucket. Okay, this is deleted. Okay, so now let me open this documentation and let me go up, guys. Okay, so after doing AWS configure, you need to check your user details, guys. Okay, so let me remove this. Needs to show only two buckets. Okay, so now let me copy this and paste it here. Okay, it needs to display my details, and this is the user ID, this is the account ID, and this is the error, guys. Okay, so already I configured this. So initially you need to create IAM access keys and secret keys, and you need to provide AWS configure, and you need to provide credentials. Next you need to run these commands, guys. Okay, terraform init plan and deploy. I forgot it to show you that, and let me copy this. Now let me paste it here. Okay, so from now it will take around 15 to 20 minutes to create all these resources. So let's wait for some time. Okay, acquiring Terraform state lock. Okay, let me do one thing. Let me come here. Let me open this banking platform and let me delete this everything guys. Okay, I'm going to delete this entire state file because we interrupted in middle, right? So it is throwing some errors. Now let me come here, Terraform init. It is going to initialize the backend, and in S3 here needs to create dev guys. Okay, let me come here. Okay, so it's initialized successfully. Okay, let me do one thing. Let me apply it. Okay, so from now it will take around 15 to 20 minutes guys. Okay, let me hit yes. Okay, so here you can see it started creating everything. Let me jump on to VPC. Okay, this is VPC, and let me refresh this page. And here you can see banking VPC. It started creating and resource map. And here you can see only VPC is created. Subnets still it is not created, guys. Okay. So from now it will take around 15 to 20 minutes. So we need to wait for some time. Let me come here and let me show you the subnets in resource map. And here you can see subnets are created, route tables are created, and public route tables are associated with public subnets, and private route tables are associated with private subnets. And here you can see internet gateway is created, and internet gateway is associated with the public route table, and NAT gateway is still it's not associated. Let me refresh this. Okay, so here you can see NAT is creating guys. Okay, so that is the reason why still it is not associated. Let me select this. Okay, still NAT is not associated. So NAT gateway has been created successfully. Let me come here and banking dev and resource map, and let me come here. So here you can see NAT is created, and NAT gateway is associated with the private route table, and private route table is associated with all the three private subnets case. Okay, so from networking side everything is completed, and let me hit S. Okay, so currently EKS cluster it's in the creating state. Let me refresh this. Okay, let me open EKS. Okay, so here you can see banking dev cluster. It's in the creating state. So now it will take around 15 minutes to create this single EKS cluster case. Okay, so I will be back once everything is created case. Okay, so let's wait for some time. So after 25 minutes, AWS infrastructure has been created successfully guys using Terraform. So now let's check all the infrastructure on AWS. So here you can see this is EKS console. And here you can see banking dev EKS cluster has been created successfully. And in compute, it's created 4 nodes with T3 X large instance type guys. Okay. So similarly, let me show you ECR repository. So here you can see this is the ECR repository banking platform, and let me open this ECR repository. Okay, so here you can see we don't have a single image inside this ECR repository guys. Okay, so similarly this is the banking dev VPC, and let me select this VPC. So inside this VPC let me select resource map. Okay, so inside this VPC it's created 3 public subnets and 3 private subnets across zones in US East 1A, US East 1B, and as well as in US East 1C guys. Okay, and all the public subnets are associated with the public route table, and all the private subnets are associated with the private route table, and private route table is associated with the NAT gateway, and public route table is associated with the internet gateway guys. Okay, And let me drop down this, and in S3 we need to create an S3 bucket. Sorry, AWS Terraform will create an S3 bucket, guys. Okay. Okay, I think we haven't applied Velero module, right? So when we apply Velero module, it is going to create an S3 bucket. So in final phase, I'm going to explain you that. So let me show you Route 53. So here you can see in Route 53, it is going to create an hosted zone with my domain name, which is vijaygudu3.in. So in your case, you need to update your domain name, guys. Okay, that's it you need to do. So now let me select here EKS. So now let's try to connect to this banking dev EKS cluster from this shell. Let me clear the screen. So the command is, let me do some spaces. Okay, AWS EKS update hyphen kubeconfig hyphen name. So the cluster name is banking dev and hyphen region US East 1, guys. Okay. So here banking dev is the cluster name and US East 1 is the region, guys. Okay. So now let me do kubectl get nodes hyphen -oy. It is going to display all the nodes in detail, guys. Okay. And here you can see we have 4 nodes. Let me remove hyphen -oy and only kubectl get nodes. And here you can see we have total 4 nodes and it's created only last 9 minutes 49 seconds ago, guys. Okay. So let me open this documentation. From infrastructure side, everything is up and running. So if you want to check all the Terraform state, you can directly run this command Terraform state list. It is going to display all the resources which is going to create, guys. Okay. And here you can see all these resources has been created by Terraform just now, guys. Okay. So everything is up and running from infra side and we can leave this everything. Okay. So now let's directly jump on to phase 2, which is Traefik Ingress controller. In phase 2, we are going to install and configure Traefik Ingress controller on our EKS cluster. So basically, Traefik is a modern cloud native edge router. It is the single front door of our EKS cluster. Every request from the internet, whether it's for our banking application, ArgoCD, Prometheus, Grafana, or Alert Manager, it lands on the Traefik first, and next Traefik decides to which internal service to forward based on URL paths case. Okay. So now let's start installing this Traefik Ingress controller on our AWS EKS cluster. So you can directly come down and this is the step 1. So basically in step 1, we are going to install Traefik using Helm. So first we will add the official Traefik Helm chat repository and next we are going to update it. Then we will run a single Helm install command with all the configuration flags. And these flags tells Helm to deploy Traefik into the Traefik namespace and with the 2 replicas and then expose on port 80 and 443 and importantly a couple of AWS specific annotations that tell AWS to create a network load balancer that is internet facing, guys. Okay. And we will also make Traefik as the default ingress class so it automatically picks up our apps routes later, guys. Okay. So basically it will take around 2 to 3 minutes to install but most of the time it will take to provision AWS network load balancer, guys. Okay, behind the scene. So now before creating this, let me check whether this Traefik Helm repository is available in my local or not. Let me do Helm repo ls. It is going to display all the Helm repositories. So let me remove this repositories, guys. Okay, because while I was testing this application, I just pulled these repositories, meaning I just added these repositories. So Helm repo remove and here provide Traefik. Okay. So here you can see Traefik has been removed from the repositories and Helm repo ls. Now let me remove ArgoCD. Helm repo remove ArgoCD. Okay. ArgoCD. Okay. So it's only Argo, guys. Okay. Argo. Now Helm repo ls. And here you can see we don't have a single Helm repository. So now let me copy this and let me paste it here. So initially it is going to add Traefik Helm repository. Next it is going to update this. Next it is going to install this. Helm chart, guys. Okay, Traefik Ingress Helm chart on our EKS cluster. Okay, so let's wait for next 2 to 3 minutes, or else let me open EC2 in a new tab, and here let me directly jump on to load balancing. Behind the hood, it will create a network load balancer, guys. Okay, so here you can see right now we don't have even a single load balancer, right? So within next 2 to 3 minutes, it will create a load balancer, guys. Okay, so basically this Traefik Ingress will create a load balancer. Okay, so here you can see update complete, happy helming. So currently it is installing this Helm chat, guys. Okay, so let's wait for next 2 to 3 minutes. So here you can see it's installed successfully. So now let me come here and let me refresh this page, and here you can see it's in the provisioning state, guys. Okay, so it will take around 2 to 3 minutes to come to active state, so let's wait for some time. In the meantime, let me open the documentation and let me come down. Okay, so in step 2 we are going to verify everything in place or not. So first we will check that the Helm release shows deployed or not. Next we are going to verify two traffic pods are running or not, and next service has external address assigned or not. Okay, and we will also confirm that all traffic CRDs are installed. Okay, and finally we will also save load balancer hostname into a variable, because we will refer to it through the next steps and in the later phases also, guys. Okay, so initially let me run this command helm list hyphen n traffic, because we created on traffic namespace, and here you can see, so it's deployed successfully. Here you can do helm list, or else helm ls is also not a problem, guys. Okay, helm ls. Okay, so it will display, guys. Okay, so you can run helm list or helm ls, anything is no problem. Now let's check all the pods inside this traffic namespace. We need to see only two pods: kubectl get pods hyphen n traffic. Inside this we need to see two pods, and here you can see two pods are in running state. Now let me check the service. Okay, and here you can see this is the traffic service. It's created with service type load balancer, and this is the external IP, guys. Okay, meaning this is the network load balancer external IP in our AWS. Let me open this and let me refresh this, and here you can see state is changed to active. Now it's working, guys. Okay, and let me keep like this. Okay, and this is the load balancer ARN. Okay, and here you can see this is the external IP, guys. Okay, now finally let me come here and let me show you all the CRDs. And here you can see these are all the CRDs for traffic. And let me save network load balancer hostname, so because we need to use this later. Okay, so now let me open this documentation. Now step 3 is optional. In step 3 we are going to send a quick HTTP probe, meaning we are going to send a simple request to our new load balancer to confirm traffic is reachable or not. At this point, no application routes yet, right? So traffic responds with a 404 node found, and that exactly we want to see, guys. Okay, so let me copy this and let me paste it here, and let me hit enter, and here you can see 404. So this is the expected output. Now let me open this documentation once again. Now step 4 is optional. If you want to access traffic dashboard, you can run this command, guys, but in this video I'm not going to access this. I'm going to skip this, guys. Okay, now let me come down, and in step 5 is load balancer hostname stability. And this is one important note. Basically this network load balancer gives us a stable DNS hostname, right, that stays the same as long as we don't delete and recreate the traffic service. Normal upgrades keeps the same load balancer. Okay, so this matters because in phase 5 we will point our domain at the same hostname using route 53 alias record. As long as we don't casually delete service, right, our DNS keeps working automatically, guys. Okay, so now this is about phase 2. So in phase 2 we completed everything. Let me copy this and let me paste it here. Okay, so it is going to show us the external IP, like, okay, So this is the traffic load balancer external IP, meaning this is the load balancer IP address, guys, in simple terms. Okay. So now let's jump on to phase 3. So let me open this documentation. So the phase 3 is GitHub Actions CI/CD. Now in phase 3, we are going to set up our continuous integration pipeline using GitHub Actions. So think of pipeline as an automated factory assembly line. So the moment we push code to GitHub, the pipeline kicks in and does everything for us, guys. Okay. It builds each service into a container image, scans each image for security vulnerabilities, and pushes the finalized image to private registry on AWS. Okay. Here is a really important design decision. The pipeline only builds and ships the images, but it never deploys to the cluster directly. It updates a version file on Git, and then ArgoCD, which we will set in next phase, notices the changes and does the actual deployment. And this is the heart of GitOps, guys. Okay. And the Git is the single source of truth, and the pipeline never deploys, and the cluster passwords are credentials, guys. Okay. So now let me open .github/workflows directory, and let me open this, and let me open this. Okay. So let me open this ci.ml pipeline. Okay. So now let me explain you how this pipeline is going to work. So the first thing is, basically we will use a single ECR repository for all our images, and we tell them apart using a tag per service like auth service and account service for one repository to manage instead of 32, guys. Okay. Now let me come down. Okay. So and the second one is we will use metric builds, which means all 32 workloads like 30 services plus API gateway plus front end build in parallel at the same time. So it's very fast, guys. Okay. And the third one is every image is scanned by Trivy, and it's a security scanner that looks for known vulnerabilities, guys. Okay. In our learning setup, it reports issues without blocking, but with one time change, it can become a hard gate that stops bad images for shipping, guys. Okay. By the end of this phase, every time we push code or images, it will build and scan and ready in AWS, guys, with the zero manual steps. Okay. So now let's set up this. So let me open this documentation once again, 03 GitHub Actions. Okay. And let me jump on to step 1. So in step 1, we need to create an IAM user for CI. So basically our pipeline needs permissions to push images into AWS, right? So we need to create a dedicated IAM user for CI, and we need to give it only that has ability to push our Docker images to ECR repositories, guys. Okay. But in this video, I'm not going to create any IAM user. I'm going to use my same IAM access key and the secret access key, guys. Okay. Now, let me come down. Now, in step 2, we are going to configure GitHub secrets and variables. So we will go into our GitHub repository settings and add the credentials like access and secret key on GitHub secrets. So they never visible in the code, guys. Okay. And we will also add few plain variables like our AWS region and the address of our registry that the pipeline uses to when to push, guys. Okay. And this is the secure handshake between GitHub and AWS, guys. Okay. So now let's add these secrets and variables. I have already added this AWS IAM access key and secret key on GitHub secrets, as well as variables like region, ECR registry, and the repository. So let me show you this. You need to open your repository and directly jump onto settings, and here directly jump onto secrets and variables and actions. Okay. So in secrets, you need to create key with name AWS access key, and inside this you need to provide your access key. Similarly, you need to select here create a new repository secret. Inside this you need to provide this name, guys. Okay. So you need to provide this AWS secret access key. Inside that value you need to provide your secret access key value, guys. Okay. So I have already added this last 3 weeks ago, but inside this secrets you need to add your AWS IAM access key and secret key. And if you want this name, you can directly take from here, guys. Okay. But here values, you need to add your IAM access key and secret key. Now when it comes to variables, you need to directly jump on to variables, select here variables, and here you need to add AWS region, ECR registry, and ECR repository, guys. Okay. And here you can see AWS region you need to provide as US East 1, and ECR repository. So here you can see simply account ID. You need to replace your account ID. In my case, this is my account ID, guys. Okay. So here you can see this is the account ID. You need to copy this account ID and you need to replace it here, guys. Okay. You need to replace it here, and next you need to copy this entire thing and you need to update it same like this. And next ECR repository, simply you need to provide your ECR repository name, which is banking platform. You can keep as it is case, okay? So here you can see this is the ECR repository name, which is banking platform. We need to keep like this, okay? So I have already added this. So now let me open this and let me directly jump on to step 3. Now in step 3, let me explain you how build job works. Okay. So let me walk through what actually happens on every push. For every service, the pipeline logs into AWS builds that contains images using a shared Docker file, runs the trivia security scan, and then pushes the image to ECR tagged with exact commit ID, guys. Okay. So we will also know precisely which version of the code is in each image. And one good thing is it uses a build cache. So after the first run, it reveals images much faster, guys. Okay. So this is about step 3. So now let me come down. And in step 4, I'm going to explain you how the GitOps update works. So after all the builds succeed, one final job runs, guys. Okay, it opens our Helm chart values file and updates each service image versions to the new one build, guys. Okay, then it commits that changes back to Git, guys. Okay, so within the GitHub repository, we have Helm chart. So inside deploy, so let me close here. So let me select your banking application EKS and you need to select your deploy and Helm banking application and values.ml. And here you can see for every service, it is going to update this image tags case. Okay, so here you can see for authentication service, we have same image tag. For customer service, we have same image tag. For profile service, we have same image tag. So let me show you the history. Okay, so here you can see this is the last 2 weeks history. So it is going to update image tags something like this case. Okay. While running this pipeline, I will show you for every service it is going to update image tags. Okay. So here you can see banking platform, statement service and report service and analytics service and search service, email service. For every service, it will update this image tag guys. Okay. So this is about step 4. So now let me come here and let me directly jump on to step 5. So in step 5, we are going to trigger and watch the pipeline. But before that, let me explain you about our GitHub Actions pipeline end to end. So you can find the pipeline inside .github/workflows directory. And here we are going to use this pipeline, which is ci.ml guys. Okay. So let me open this ci.ml pipeline. And first, let me explain you about this pipeline, guys. Okay. So here you can see initially in line number 27, it is showing name. Name is nothing but it's, let me close this. Okay. So name is nothing but it's just the display name of our pipeline. Like it will display CI AWS/ECR shows in GitHub Actions tab, guys. Okay. I will show you that later. And here you can see on push. Okay. On push and pull request. Okay. So this pipeline runs automatically on every push or peer to the main, but only when related files changes like services, front end, Helm chart, etc. guys. Okay, unrelated changes, this pipeline will not trigger, guys. Okay, it needs to trigger only services directory changes or front end or packages or builds or Helm chart, or if we modify on pipeline, this pipeline is going to trigger, guys. Okay. And next in line number 43, here you can see paths 34 as well as in 43. So this is the filter that decides what counts as a relevant, guys. Okay. And now here you can see in line number 51, we have workflow dispatch, meaning so we can manually trigger the whole pipeline from the GitHub UI with a button on demand, guys. Okay. And I'm going to show you that later. And here you can see in line number 53, we have a concurrency block. So if we push twice quickly, it cancels the older runs. So only the latest one continues and saves times and avoids clashes, guys. Okay. And here you can see in line number 57 and 58, which is permissions read. So by default, the pipeline can only read the repo and nothing else, guys. Okay. This is the least privilege we are going to provide. And in line number 60 to 64, we are going to pass env variables. So we are going to take AWS region and image prefix from the variables, guys. Okay. Now, let me come down. So these are all the jobs. So now the first job is build and strategy. So we are going to use matrix. So basically this is the parallel factory. It visits all 32 workloads and runs a separate build for each one of the same time, guys. Okay. So parallelly it is going to build all these services Docker images. So let me close this case. Okay, so in line number 76, you can see it is showing fail fast equal to false. So if one service fails, the other keeps building instead of all stopping. So we can see every failure at once case. Okay, so now let me come down. So here you can see in matrix, it is going to build all these services in parallel. So now let me directly jump on to step one. So in step one, it is going to check out the repository, meaning it is going to pull our source code into the runner. So in step two, let me cancel this. Okay. So basically in step two, it is going to compute shorts. It grabs the short commit ID and becomes the unique image tag, guys. Okay. So we can always know which code is in each image. Now, this is step 3. So in step 3, it is going to resolve build inputs. So it picks the right Docker file and the front end has its own, and all backend services shares one common Docker file, guys. Okay. So this is about step 3. So step 4 is configure AWS credentials. So basically it logins to our AWS using our stored IAM access keys and secret keys. So here you can see it is going to take this IAM access key from GitHub secret. Similarly, it is going to create take secret access key from secrets case. Okay, so here you can see secrets.aws access key, secrets.aws secret key. Okay, and similarly it is going to take region from envvs case. Okay, now this is step 5. So in step 5, it is going to log into ECR. So it is going to authenticate Docker to our private ECR repositories to push our Docker images later, guys. Okay. So step 6 is setup Docker build. It enables the advanced Docker builds that supports caching and faster builds, guys. Okay. And this is step number 7. So basically it is going to build images locally for scanning. In this step, it is going to build the images, but it doesn't push, guys. Okay. It loads it locally first. So we can scan it before shipping. Okay. Now let me come down. So the step 8 is review image scan. So it is going to scan the built images for high and critical security vulnerabilities case. Okay. And this is step 9. So in step 9, it is going to push images to ECR only on main branch. It pushes the scanned images to ECR with the two tags, which is first one is with the commit ID and the second one with the latest image tag, guys. Okay. So this is about job 1. So this is about job 2. So second job name is update GitOps. So here you can see it is showing uh, needs build. Okay. Let me cancel this once again. Okay. In line number 195, it is showing needs builds, right? So basically this job waits until all 32 builds finishes successfully before it runs case. Okay. Once job 1 is completed, next it is going to start this job 2. Now, so here you can see this is step 1, which is checkout repository. It checkouts the code again, this time with write access. So it can commit back, guys. Okay. So here you can see permissions. We just provided content equal to write. Okay. So here you can see this is step 2 install 𝐰𝐿. So basically it installed a small tool for editing YAML files from command line, guys. Okay. Now this is step 3. So in step 3 it is going to update image strings in Helm values.yaml file. So it goes through every service and updates its image version in the Helm values file to the one it builds, guys. Okay. So I will show you this later. So here you can see this is the final step, which is commit and push GitOps update. So it commits the changes with the skip CI tag and pushes it, and this commit is what ArgoCD detects to trigger the actual deployment, guys. Okay. So this is our main CI pipeline, and apart of this, we have second pipeline which is terraform.yaml. So let me open this terraform.yaml pipeline. So now let me keep like this. Okay. So now let me explain you about this pipeline. So basically this pipeline is purely a safe check and it formats and validates our Terraform for all three environments on every change, but it has no AWS credentials, guys. Okay. And never creates or destroys anything. Actual infrastructure changes will still run from local, guys. Okay. So now let's trigger this ci.ml pipeline. So before triggering this pipeline, let me show you this ECR repository. So let me open this ECR, and this is the ECR repository, right? Let me select here ECR repositories. So banking platform. So inside this banking platform ECR repository, right now we don't have even single Docker image, right? So when we build this ci.ml pipeline, automatically it will build all the 32 services Docker images, and it is going to push those images to this ECR repositories. Next, it is going to update those image tags on helm values.ml file, guys. Okay, so I will show you now. Or else before triggering this ci.ml pipeline, let me trigger this terraform.ml pipeline, guys. Okay, so let me directly jump on to actions, and here you can see terraform ci. Okay, let me open this and run workflow, and branch is main. Okay, so we have only single branch, which is main. Now run workflow. Okay, so here you can see it is going to test our terraform scripts, guys. Okay, so in dev qa and prod on 3. Okay, let me open this. It is going to check everything, and here you can see first it is going to check terraform format. So format is good, so it is not going to initialize the backend. Okay, and it is going to validate. So here you can see success, the configuration is valid. Okay, so it is going to run this sample checks, guys. Okay, you can directly check the format and everything using this terraform pipeline. Now let me trigger this actual pipeline, guys. Okay, so this is our actual pipeline. Let me go back and run workflow, and which is branch is main, and run workflow. Okay, so now we are going to trigger this ci aws/ecr pipeline. Okay, so here you can see now it started building all the 32 services Docker images. So after building these 32 services Docker images, right, it will parallelly push these images to this ECR repository. Right now it is showing no active images, right? So once the pipeline is green, it is going to display all these 32 services Docker images on this ECR repository. And parallelly, let me go back from this. Okay, and let me select here banking application EKS. Okay, and now let me select here deploy, and here this is our Helm chart, banking application Helm chart, guys. Okay, and in Helm values dot, and here you can see Helm values dot ml file is updated last 2 weeks ago. Now let me open this, and here these are all the old image tags, right? So within some time it will update our new image tags, guys. Okay, so I will show you that. And here you can see 16 images has been built at 17 it's complete, 18 it's complete, 19 it's complete. Okay, 19 in the sense it's created 19 services Docker images, guys. Okay, so build is complete for 19 services. So similarly we need to wait for 32 services, guys. Okay, so once this is completed, all the image tags will be updated in this Helm chart, guys. Okay, I will show you that now. And here you can see 24, 25, 25 services build is completed, 26 builds is completed. And here you can see 31, 32, all the 32 services builds are completed, and finally it's updating GitOps, guys. Okay, meaning it is going to update our helm values.ml file. Okay, so let me show you that. Let me refresh this page, check out repository, update GitOps. I think everything is completed, guys. Okay, let me come up. Okay, let me come here and let me refresh this page. Here it is showing. So here you can see previously it has showed 2 weeks ago, but now it is showing now, guys. Okay, so let me show you the history, and here you can see committed just now, right? Let me open this, and here you can see this is our old image tag, and this is our new image tag, guys. Okay, so now in next phase ArgoCD will deploy these Docker images, guys. Okay, so the flow will be like whenever if you do any changes to any of the microservices or Helm charts or the pipelines, right? So this pipeline is going to build all the Docker images, and it is going to push those images to ECR repository, and parallelly it will update all the image tags. So here you can see this is the update GitOps, right? So here you can see this is the banking platform, account service, admin service, platform analytics service, API gateway service, audit service, auth service, and beneficiary service, card service, currency service, customer service. For every service, it has updated same image tags, guys. Okay, and all these image tags will be updated on this helm values.ml file, guys. Okay, so here you can see this is the helm values.ml file. So if any changes are happened in this helm values.ml file, right, ArgoCD will sync these changes, meaning ArgoCD will deploy these images to the EKS cluster, guys. Okay, so this is what we called as GitOps. Okay, so now this pipeline is green. Now let me come here, and this is the ECR repository, and let me refresh this. And here you can see all the services Docker images, guys. Okay, so all the services Docker images are available inside this banking platform ECR repository. Okay, so this is about phase 4. So now let me open this. Okay, so our pipeline is also green. Now let me select here docs and AWS, and now phase 4 is ArgoCD, guys. Okay, so before starting this phase 4, let me show you all the services in which directory you can find. So let me come up and let me select here banking application EKS. So you can find all the services inside this services directory. So I forgot to show you guys. Okay, so here you can see these are all the services. So inside services directory you can find all the microservices like account service, admin service, analytics, API gateway, audit, auth, beneficiary, card, currency exchange service. So you can find all the services inside this services directory. But the good thing is, for every service we have only single Docker file, guys. Okay, so basically these are all the backend services. For all the backend services we have only single Docker file, and you can find that Docker file inside this build directory, guys. Okay, so you can directly drop down this, and here you can see service.docker file. So using this single Docker file, we are going to build all the services Docker image, guys. Okay, meaning for all the services we are using this single Docker file, and this is for backend. And for front end we have individual folder. So here you can see this is front end, and this is the front end Docker file, guys. Okay, but for backend we have only single Docker file for all the microservices, guys. Okay, so now let me open these docs and AWS, and this is phase 4. Okay, now in phase 4 we are going to install ArgoCD and set up GitOps. So ArgoCD is nothing but it's a GitOps engine, and the idea behind it is beautifully simple. So Git is the single source of truth. Whatever we have defined on our Git repository, ArgoCD continuously makes the cluster match it automatically, guys. Okay, so here is the complete loop we are going to build. If I push code to GitHub, right, so GitHub Actions build the images and updates a version file in Git, and then ArgoCD notices that changes, and ArgoCD deploys that new version to the cluster from that point on, guys. Okay, so there is no manual deployments anywhere, no Helm install, no kubectl apply commands, guys. Okay, and the best part is self-healing. If anything in the cluster drifts away, what's in the Git, like if someone deletes a pod or changes settings by hand, ArgoCD notices that automatically and it fixes its back to Git, guys. Okay, so always it will match with Git and the cluster, guys. Okay, so we will also use a clever pattern called app of apps. Instead of deploying 12 applications one by one, we will apply just one root application, and it automatically creates all the others like the booking platform, monitoring, TLS, backups like Valero, everything it is going to create, guys. Okay, and by the end of this phase, all this entire application will be running on the cluster fully managed by Git. So now let's set up this ArgoCD. So now let me directly jump on to step 1. So we can directly skip this step 1, guys, because while I was testing this Helm chat manually, I just updated this command. Okay, so now let me directly jump on to step 2. In step 2, we are going to install ArgoCD itself using Helm into its own ArgoCD namespace. So we will configure it to run behind our existing Traefik load balancer. So no second load balancer is needed, guys. Okay, and to serve its UI under slash ArgoCD path within a couple of minutes, guys. Okay, and all ArgoCD components come up and ready, guys. Okay, so now let's try to apply this. So initially we are going to add ArgoCD Helm repository, and next we are going to update this, and next we are going to install this, guys. Okay, in ArgoCD namespace, so we are going to create with type cluster IP, and in secure we are going to provide as true, and we are going to access ArgoCD at path slash ArgoCD, guys. Okay, now let me copy this and let me come here and let me paste it here. Okay, so now it is going to install this. So here you can see ArgoCD repository has been added successfully to our local, and update is also complete. Happy helming. Currently it is installing this ArgoCD Helm chat test. Okay, so now let's wait for some time. In the meantime, let me open the documentation and let me come down. So once after created this Helm chat, right? So we need to check all the pods inside this Argo CD namespace, guys. Okay, not only pods, let's check all the services, deployments, and everything, guys. Okay. So meanwhile, let me come here. So it's still in the installing state. So let's wait for some time. And here you can see after 2 to 3 minutes it's installed successfully. So now let me check this helm ls-a. So it is going to display all the helm charts from all the namespaces case. Okay, and here you can see argo cd namespace has been deployed. Sorry, argo cd has been deployed on argo cd namespace. So if you want to display only argo cd, right, so you can directly run this command helm ls-n argo cd. Okay, so it is going to display the Helm chart in Argo CD namespace. So here you can see now it is displaying only Argo CD. Okay. So if you want to display all the Helm charts from all the namespaces, you can directly run this command, guys. Okay. Now let's check all the pods inside this Argo CD. kubectl get pods and Argo CD. We need to see all the pods in running state, guys. Okay. And here you can see for Argo CD, all the pods are in running state. Now let me check all. Okay, it is going to display all the pods, deployment services, replica sets, stateful sets, and everything it is going to display this. Okay, and here you can see when I select kubectl get all hyphen and argo cd, so these are all the pods for argo cd, and these are all the services for argo cd, and these are all the deployments, and these are all the replica set, and this is the stateful set for argo cd. Okay, so everything has been installed successfully. So now let me open our documentation once again. Okay, now this is step 3. So now in step 3 we are going to expose Argo CD dashboard. So we will make Argo CD dashboard reachable through our domain by adding a traffic route for slash Argo CD path, guys. Okay, so now let's apply this. Let me copy this and let me come here. Okay, let me copy this once again. Okay, let me come out from this directory first. Okay, and let me paste it here, guys. Okay, so basically we are going to create ingress route for traffic, guys. Okay, now we need to access argo cd with our traffic ingress external ip with the slash argo cd. Okay, and here you can see this ingress route is routing traffic to this argo cd server, and here you can see this is the argo cd server. Okay, so to this service this ingress route is routing, guys, behind the hood, and port is 80, and name is argo cd namespace. It's created on argo cd namespace, and the path is slash argo cd. Okay, and priority we provided 100, guys. Okay, meaning anyhow it will route traffic to this argo cd. So now let me open this documentation once again. Now let's verify whether it's reachable or not. Okay, let me copy this, paste it here, and here you can see it's showing 200, meaning it is working, guys. Okay, so now we need to access like kubectl get service hyphen in traffic. Okay, we need to access argo cd with this external ip. Okay, with this external ip slash argo cd slash. Okay, so we can directly open our argo cd ui. Now let's open argo cd ui. Before that, if you want to get argo cd url like with the load balancer external ip slash argo cd and as well as username and password, you can directly run this command, guys. Okay, copy this command and paste it here. Okay, me copy it once again, paste it here. First it is going to display the url. So here you can see http colon slash slash. So this is our load balancer external ip and slash argo cd, and this is the argo cd username, and this is the argo cd password. So now let me try to access this, copy, and I'm going to open this in incognito window, guys. Okay, and here you can see we can able to access argo cd. Now the username is admin and password. We can get this password from here, and this is the password and sign in. Okay. So here you can see we connected to ArgoCD UI, guys. Okay. So now let me come here. And the second option is if you want to access using port forward, you can directly run this command, guys. Okay. But the preferred one is this. So you need to create ingress route, and next you need to check whether it is reachable or not. Once if it is reachable, right? So you can directly run this command. So this command is going to show you the URL to access ArgoCD UI. So this is the URL and this is the username and this will be your password, guys. Okay. So now let me come down and you can leave this everything, guys. Okay. Now let's directly jump on to step 4. In step 4, we are going to give ArgoCD access to our GitHub repository, right? So basically, ArgoCD needs to be able to read our repository. So since Git is its source of truth, our repository is private. So we are going to give ArgoCD read access using GitHub personal access token, guys. Okay. So we are going to store securely as a GitHub secrets in the cluster, guys. Okay. So now initially you need to jump on to settings, developer settings, personal access tokens, and you need to generate a classic token, guys. Okay, so already have generated this token. So here you can see this is my GitHub personal access token, and if you want to create this, you can directly jump on to settings and let me select this profile and settings and directly jump on to developer settings and personal access tokens and token classic, guys. Okay, so here you can see banking application EKS. So already have created this, so you need to select here create new token and here you need to select generate new token and you need to create a token, guys. But anyhow I'm not going to create a token because token is already available with me, guys. Okay, so this is the token I created while I was testing this application. Okay, and I'm going to use that same token now. This is the token, right? So in your case, you need to create a token first. Okay. So once after creating this token, you need to create a Kubernetes secret using your token. Okay. I'm going to copy this and I'm going to paste it here. And this is my GitHub token. And I'm going to replace it here, guys. Okay. So here you need to replace your token. And the thing is, you need to update your repository URL, guys. Okay. So you can get this repository URL from here. Let me directly come out from this, copy this and directly copy this repository URL and update here, guys. Okay. Next, you need to update your GitHub username and here you need to update your GitHub personal access token, guys. Okay. This will be your password. Okay. So now I'm going to copy this and I'm going to paste it here. Okay. So now it is going to create a secret. Let me open this documentation now. Once after creating this, we need to verify this case. Okay, we need to verify our created secret, which is banking repo secret. We created this on ArgoCD, guys. Okay, and once we are applying this, right, we need to see this label, guys. Okay, so this is the label argocd.argoprojects.io secret type equal to repository. Okay, we need to see this. Let me copy this. Okay, it's created and let me paste it here. Okay, we need to see the same label. Okay, so this is the label and here you can see we are going to see the same label and it is going to work now. And this is the final step. So step 5 is bootstrap GitOps, meaning this is the moment everything comes together. So we will apply just two files. One defines the project and other is the root application. The root application is the app of apps that instantly we apply it. ArgoCD reads our repo and automatically creates all 12 applications like the banking platform with its 30 plus services and cert manager and the entire monitoring stack and Valero for backups and everything it is going to create, guys. Okay. So now let's apply these two files like project.ml and root app.ml. Slowly ArgoCD dashboards lights up one by one. Every application turns green, guys, but it will become sync and healthy with zero manual deployment, guys. Okay. So now let's apply these two files, which is project.ml and root app.ml. Then slowly ArgoCD dashboards lights up as one by one. Every application turns greens. It will become sync and healthy, guys, with the zero manual deployments on our part in a couple of minutes, guys. Okay. So the whole application will be live in our cluster case once these two are applied. Okay. So now, if you want to check this project.ml and the root app.ml, you can directly check this in ArgoCD, deploy ArgoCD bootstrap guys. Okay. And this is deploy and ArgoCD, and this is bootstrap. Okay. And this is the project.ml file. Okay. And this is the root app.ml guys. Okay. So okay, so now I'm going to apply this. So before applying these two files, let me come here. Let me open ArgoCD, okay? And let me refresh this page. And here you can see we don't have even single application, right? So now I'm going to apply these two files, okay? So it will create all the applications guys, okay, within 1 or 2 minutes it will come to sync and healthy. Also initially it will show unhealthy, but within some time it will show healthy. In the meantime, let me keep hyphen watch kubectl hyphen and ArgoCD get applications hyphen watch. So here you can see it's creating guys. Let me come here, and here you can see banking platform set manager, issuer, loki stack, Prometheus stack, cluster storage, and everything it is creating guys, okay. And in next page here you can see tempo velero. So currently here you can see missing out of syncing. Okay, it is showing like this, but it will take around 2 or 3 minutes to come to in sync guys, but 100% it will come to sync status guys. Okay, so here you can see it is showing degraded, right? Look carefully, within next 30 seconds to 1 minute it will come to healthy state, because few pods are in deploying state, right? So here you can see auth service it is showing degraded, and as well as card service, document service, it will come to running state. So let's wait for some time. In the meanwhile, if you want to check this in background, right? So here you can see all the ArgoCD applications are coming to progress, healthy, processing, healthy. Okay. It will come to insync guys. In the meantime, let me check our main application, kubectl get ns. And here you can see ArgoCD is currently deploying our banking application, set manager, and observability stack, Velero. Okay, all four it is deploying. Let me check our banking application pods, kubectl get pods hyphen n banking. And here you can see inside banking namespace, all our pods are in running state, guys. Okay. So account service, admin service, analytics service, API gateway, audit, authentication, beneficiary service, card, currency, email, EMI, fixed deposit, fraud service, front end service, investment service. All the services are in running state, guys. Okay. So now let me check this, and it is showing still degraded. Let me refresh this. Okay, it is showing synced, sync is okay, and here you can see it change it to healthy. Okay, so it will come to healthy guys. Okay, it will take around 2 to 3 minutes, that's it. Okay, and here you can see most of are in green, and still loki stack is in processing state. Let me come here, let me run this command to check all the ArgoCD applications. And here you can see a part of loki stack, all are in healthy state guys, as I said. Okay, it will take only 2 to 3 minutes guys. Okay, so let me do one thing. It's loki stack, right? kubectl get ns, and I think it will be deployed on observability. kubectl get pods hyphen n observability. Observability loki will be deployed on observability. And okay, okay, loki. Okay, loki stack is up and running guys. Okay, so here you can see one by one it's running. Let me check the ArgoCD UI. So here you can see loki stack is healthy, it is showing. Okay, so Prometheus stack is currently it's in the syncing state. And here you can see metric server deployed, observability deployed, open telemetry deployed, platform root. Okay, and Velero, it's for backup and restore. It's showing synced and healthy, and tempo is also deployed guys. Okay, it's open telemetry thing, and everything is deployed. And here you can see observability stack earlier. Okay, Prometheus stack earlier it is in processing, right? So now it is showing synced. Now let me clear the screen. kubectl get applications hyphen and ArgoCD. And here you can see everything is in sync, guys. A part of platform root, so this will be out of sync, so this is expected, but a part of this everything is deployed, guys. Okay, so this is the power of GitOps, guys. Okay, everything has been deployed successfully. So now let me open this documentation. Okay, so we just checked our banking application, right? So this is also synced, which is banking platform. Let me show you this. And here you can see banking platform. And if you want to check inside this, you can directly come here, banking platform. And here you can see these are all the services. Let me zoom out. Okay. And here you can see account service, admin service, analytics service, API gateway, audit service, auth service, beneficiary service, card, currency, customer, document, email, EMI, fixed deposit, fraud service, front end service. Everything is deployed, guys. Okay. And this is deployed using our Helm chat. I forgot it to show you the Helm chat also. Let me show you that. Okay. So inside deploy, you can open this Helm banking application, and here you can see these are all the templates for our microservices, guys. Okay. So inside every service, you can find the deployment. So for example, this is the wallet service. This is the wallet service deployment, and this is the wallet service, and this is the wallet service config map, and this is the wallet service secret, and this is the wallet service horizontal pod autoscaler, guys. Okay. So similarly, for every service, you can find all the deployments, services, config maps, secrets, and horizontal pod autoscalers, guys. Okay. So these are all the services, and we are passing all the values from values.ml file. So basically this is the values.ml file, guys. Okay, and we directly integrated this Helm chat with our ArgoCD application, guys. Okay, and if you want to check all the applications, you can directly open this ArgoCD and apps, and here you can see you can find every application, guys. Okay, so here you can see this is the banking application ML. So this is the repo URL. GitHub vijay.in/ banking application EKS.git. Okay. And the target branch is main. And the path is deploy Helm and banking platform. This is the Helm chat case. Okay. So here you can see deploy. This is the path, and Helm banking platform. This is the one. Okay. So values from is values .ml. Okay. So this is how this is for set manager, cluster issuer, and this is set manager, and this application is for metric service, and this application is for storage. Okay, so everything, all the services we deployed using ArgoCD applications, guys. Okay, and these are all the applications. In UI you can see something like this, guys. Okay, so let me open this documentation now. This phase is also completed successfully, guys. Okay, and I just forgot it to show you the pods, like all the services on set manager namespace and observability namespace, right? So let me show you this. Let me cancel this. Now kubectl get ns. I just showed you only banking application, right? So now let me show you kubectl get all hyphen n. Let me show you for cert manager, and inside this, you can see all the pods deployment services, right? Okay. So here you can see this is the set manager pods, and this is the CA injector, and this is the webhook, guys. Okay. And this is the set manager service and webhook service. And this is the set manager deployments, CA injector deployment, webhook deployment, guys. Okay. Similarly, these are the replica sets. So this is for set manager. So next, let me show you observability. So this is very important thing. Okay. So kubectl get pods hyphen n, sorry, kubectl get all hyphen n observability. It is going to show you all the resources. And here you can see inside observability, we have all the Prometheus stack as well as Loki stack as well as open telemetry also, guys. Okay. And these are all the services. And these are the daemon set, deployment, and replica set. Okay. So everything is deployed successfully. And these are the stateful sets, guys. Okay. Now finally, let me show you the last one. I think Velero. Okay, so this is the Velero, which is for backup and disaster recovery. kubectl get pods hyphen and Velero. Okay, it is going to display all the pods, deployment services, and replica sets for Velero, guys. Okay, so here you can see These are the Velero related pods, and this is the cluster IP service. This is the daemon set, this is the deployment, and this is the replica set. And these are all for Velero, guys. Okay. So everything is deployed using this ArgoCD, guys. Okay. So now phase 4 is completed successfully. So now let's directly jump on to phase 5, which is DNS. Now in phase 5, we are going to point our domain, which is vijay.giduturi.in at the cluster. Since a bare domain can't use a normal CNAME to reach our AWS load balancer, we host DNS in Amazon Route 53, which has a special alias record, then can GoDaddy stays our register. We just do a one-time name server handover to Route 53 and Terraform manages the rest, guys. Okay. And by the end, anyone can reach our app just by typing domain, which is vijay.giduturi.in, guys. Okay. So initially we need to export this domain, guys. Okay. So let me copy this. In this case, you need to update your domain name. Let me give some spaces. Okay. So now let me open step 1. So now in step 1, we are going to read the Route 53 name servers. So Terraform has already created our Route 53 hosted zone, right? So first we simply read our 4 name servers it's generated, guys. Okay. And these are the addresses we will handle on GoDaddy, guys. Okay. So now let me copy this and let me paste it here, guys. Okay. It will enter into Terraform environments and dev, and it will show us the output of Route 53 name servers, guys. Okay, and here you can see these are the 4 name servers, and let me come here. So it's already available, guys. Okay, so if these name servers are not available, you need to just apply this command. That's it, guys. Okay, and this is the command to check in CLI, and if you want to check from UI, you can directly open this Route 53, and this is the hosted zone, right? And here you can see this is the NS stands for name servers, and let me select this, and here you can see these are the 4 name servers, and you can find these 4 name servers here also, guys. Okay, now let me open this documentation and let me directly jump on to step 2, guys. Okay, so now in step 2 we are going to delegate GoDaddy to Route 53, and this is the only manual GoDaddy step, guys. Okay, so we need to log into Route 53. So we need to go to our domain name server settings and replace GoDaddy name servers with our 4 Route 53 name servers in step 1, guys. Okay, so now let's change these 4 name servers on GoDaddy. Okay, so you need to jump onto your GoDaddy account and DNS name servers change, and you need to enter the 4 name servers, guys. Okay, so let me open this account. Okay, so this is my GoDaddy account, and here you can see vijay.giduturi.in, and this is my old name servers, guys. Okay, so 22, 42, 25, 29, right? So here you can see it's different, 31, 05, 35, 03. Okay, so this is different. So while I was testing this application, this is my old name servers. So I'm going to change these name servers. And here you can see these are the 4 name servers we can find in CLI also. And this is using this Terraform output command, we can get this Route 53 name servers output, guys. Okay. But you can copy from here, or else you can directly copy from the Route 53 AWS console also. Anything is no problem. Okay. First I'm going to copy this 31. Let me remove this 22 and 31. Okay. So the second one is 05.com. Okay, and here 05.com. Fine. Now the third one is 35.net, 35.net, and the fourth one is 03.co.uk. Okay, 03.co.uk. Save and continue. Okay, so it's telling it's updated. Let me refresh this. Okay, so we are updating your name servers. Refresh to check. Okay. So here you can see 3105, 3503. Okay, so it's in GoDaddy, it's successfully updated the name servers. But let me open this documentation. Okay, this is the documentation. Now let me come here. So it will take some time to update this 4 name servers, guys. Okay, sometimes it will update in less than 10 minutes. Sometimes it will take 30 minutes. Sometimes it will take more than 1 or 2 or 3 hours also, guys. Okay, so let's wait for some time. In the meantime, let's complete our other steps. So let me directly jump on to step 3. So now in step 3 we are going to create the apex alias record, guys. Okay, so Terraform creates a special alias record. So we will flip one setting to true and we are going to apply. So Terraform automatically finds our traffic load balancer and points the apex domains right at traffic load balancer, guys. Okay, so now let me copy this directly. Okay, let me copy it once again. Paste it here. Okay, let me come out from this and let me come out from Terraform also. Now let me paste it here. Now it will update, guys. Okay, and once after updating this, we need to verify this. We need to it needs to display vijay.github.in, guys. Okay, let me copy this. Okay, so it's updating. Let me select here as. So it's creating the apex record, guys. Okay, so let's wait for some time. It will complete in less than 30 seconds, guys. Okay, so once after completing this, we need to verify using this command, guys. Okay, so here you can see it's applied successfully. Let me check this. Okay, so here you can see vijay.github.in, guys. Okay, so it's updated successfully. So now this is step 4. So in step 4, we are going to verify DNS resolution using dig or nslookup command. And our domain should return our load balancer actual IP address, case. Okay, but it will take some time, as I said. Okay, but let me do this. Let me run this nslookup. In hostname, in the very first here you can see I just updated this hostname equal to vijay.github. Okay, so it is going to take that hostname, guys. Okay, nslookup. Okay, it's still not updated, guys. Okay, so it will take some time, guys. Okay, so 404. Okay, so let's wait. So in the meantime, let me explain you about step 5. So in step 5, we will point the app at the domain. So we need to do one small edit on helm values.ml file. We need to change this host to vijay.github.in. Okay, so in my case, it's already updated to vijay.github.in. But in your case, you need to update this host, guys, which is vijay.github.in. Okay, with your domain. Sorry, not with vijay.github.in. In my case, my domain name is vijay.github.in. So here you can see I just updated with my domain. But in your case, it will be some different domain, right? So you need to update with your domain name. And if you want to check this, you need to enter into this part deploy Helm banking a platform and values.ml, guys. Okay, let me come here and let me go back. And here you can see deploy. And next we need to go to Helm. And next we need to go to this values.ml file, guys. Okay, and here let me search for host. Okay, so here you can see host you need to keep as your domain name. In my case it's vijay.github.in, but in your case you need to update this domain and automatically this pipeline will trigger and it will update the ingress with this host, guys. Okay, with your host name it will update, guys. Okay, but in my case this is completed. I'm going to skip this. Now let me open this terminal. Okay, still it's running. Let me cancel this, guys. Okay, no problem. But let me come down and we can skip this everything. Now we can also skip this step 6 and we need to access our banking application and ArgoCD with our domain name, guys. Okay, but it will take some time, as I said. Let me check that, guys. Okay, so let me copy this command. So when we run these commands, right, so it will access with HTTP with our host name. So in my case, it will access with vijay.github.in. It will check for banking application and it will check for Argo CD also, guys. Okay, and we need to see expected output as 200. Let me check this. So here you can see it is showing 000 for all the three, meaning name servers haven't, meaning DNS records haven't updated, guys. Okay, so as I said, it will take some time, guys. Okay, Sometimes it will complete in less than 10 minutes, sometimes it will take more than 1 hour, 2 hours also, guys. Okay, so we need to wait for some time. In the meantime, let me copy this, let me paste it here. So here status code, it is showing 200. Okay, this is good. Okay, let me copy this, let me paste it here. Okay, ns lookup vijay.gidturi.in. Okay, so let's do one thing, guys. Okay, let's try to access our application using our domain name, or else, okay, let's try to access here. Parallelly, let me try to access in incognito window also. Okay, so this is our main application, so it's unable to access case. Okay, so the second one is with /ArgoCD. Okay, let me copy this, let me paste it here. Okay, okay, so it will take some time to access, guys. Okay, let me come here and let me test this once again from our local. We need to see status code as 200, guys. Okay, let's wait for some time, something it is loading. In the meantime, let me come here. Okay, site can't be reached, meaning this is not working. Reload. Okay, let me open this. Okay, so I will be back once all the checks are showing 200, guys. Okay, because DNS needs to be updated, it will take some time, guys. Okay, that is not in our hands, so let's wait for some time. Okay, so now here you can see after 30 minutes I can able to access my banking application as well as ArgoCD with HTTP, guys. Okay, so here you can see browser is showing not secure warning for both the services. Okay, so this is our main banking application. I'm going to access with my domain/login. Okay, and ArgoCD I'm going to access with vijay.gidturi.in/ArgoCD, guys. Okay, so now first let's try to log into this ArgoCD UI. So you can directly get this ArgoCD credentials from the documentation. You can directly open. Let me close this docs and AWS and ArgoCD. Okay, so inside this you need to copy this 3a command, guys. Okay, so let me copy this, let me paste it here. It is going to provide us ArgoCD username and password, and here you can see username is admin and this is the password. Okay, so let me copy this password and I'm going to connect to ArgoCD UI with my domain name, guys. Okay, so the username is admin and this is the password and sign in. And here you can see it successfully connected to our ArgoCD UI with our domain, guys. Okay, right now we are accessing with our domain, and here you can see banking application, set manager, issuer, Loki stack, Prometheus stack, cluster storage, metric server, observability stack, hotel collector. Everything is in sync and healthy state, guys. Okay, so here you can see everything is in sync and healthy state. So now let's try to create an account, guys. Okay, so let me select here create account. So let me provide account name as demo@gmail.com. You can directly provide any dummy emails, guys. Okay, because we created this application only for learning purpose, right? So you can create dummy. So let me copy this and let me remove up to demo. Okay, so this is the full name. Email is demo@gmail.com. Password is demo@123. Okay, so create account. Account has been created successfully, guys. Okay, so this is the account. So now this is the dashboard. So user is demo@gmail.com. So the roles is customer. So right now for this customer he has 0 accounts. So now let me open an account which is savings account in Indian rupees. Open account. Okay. So one account has been opened and this is the account ID. Now let me open another account. Let me open savings account with USD. Okay. Open account. Okay. But here you can see we don't have even single Indian rupees, single USD. Now let me select here deposit. So Indian rupees amount is, let me provide 1,000 rupees and deposit. Okay. So here you can see deposited 1,000 rupees, and let me check for Indian rupees, and here you can see 1,000 rupees has been deposited successfully, but USD we don't have anything. Now let's transfer 10 USD to this account, guys. Okay. From Indian. Let me select this. Mm, from account is this, and let me copy two account. Okay. Accounts. This is the two account ID. Okay. And transfer. So from account is this, and two account is this, and amount is okay 10, and currency is USD. Okay. Okay, let me select Indian rupees. Okay. Ledger service not available. Okay. So let me check this. kubectl get codes hyphen n banking hyphen n ledger. Okay. Sorry, pipe symbol grep ledger. Okay. Let me check this service is in running state or not. Okay. Let me do one thing. Okay. So here you can see ledger service is running from last 57 minutes, guys. Okay. But I think there is some miscommunication in the code itself, but I will fix that code, guys. That is not a big problem. I will fix that later. But this application will work something like this, guys. Okay. And if you want to create a card for your accounts, so this is our two cards, right? You can directly select your card. And if you want debit or credit, you can directly select this and issue card. And here you can see this is the card and this is the Visa debit card. And if you want to apply for any loans, you can directly select the account ID and principal and annual rate and tenure, and you can directly apply for loan. Okay. So this application is mainly created only for learning purpose case. Okay. But you can directly see this entire flow, entire this DevOps flow, and how this application is deploying, how the infra is creating. You can see everything. Okay. But a part of this application. Okay. In real time, we will follow this same approach. Now, let me open this documentation, and let me open DNS is completed. So successfully, we are currently accessing our UI and ArgoCD with our domain name, right? So now it's completed. Now let me select 06 observability, guys. Okay. Now in phase 6 we will set up observability, and this has ability to monitor, measure and understand everything happening in our platform. And the nice thing is, because we are using GitOps and this entire stack was already installed automatically back in phase 4 when Argo CD is deploying the app of apps, right? So this phase is already about understanding what we have and seeing in action, guys. Okay. And here basically observability stands on three pillars, and we cover all three pillars, guys. Okay. So the first one is metrics. So these are the numbers like how many requests, how fast, how much CPU and memory this is collected by Prometheus case. Okay. And the second one is logs. So these are the details, text records from every service all gathered in one place by Loki guys. Okay. And the third one is traces following a single request as it hoops across multiple services powered by Tempo and Open Telemetry guys. Okay. And we tie all together to Grafana, which turns all these into visual dashboards, plus Alert Manager, which notifies us the moment something goes wrong. Okay. And real power is that these are connected. If a request is slow, I can look at metrics and click into logs for that exact moment and jump straight to the traces to see previously which service caused by delay, metrics to logs to trace all linked case. Okay. And by the end of this phase, we will have a complete visibility into our platform and a live dashboard for every service. Now, let's have a look on this. So now let me directly jump on to step one. So here you can see this is step one. In step one, we are going to confirm our stack is running or not, because ArgoCD already installed everything, right? And we can start by simply confirming it's all healthy. And we will check all the observability pods like Prometheus, Grafana, Loki, and Tempo, and Open Telemetry Collector, and Alert Manager up or not. Okay. And their storage is properly attached or not. Okay. So now let's check this. So let me come down. And apart of this, if instead of ArgoCD, if you want to directly create this observability stack, right, you can directly run this commands case. But in this video, it is not necessary to run these commands and everything. And if you want to run as a single script, you can directly run this install.sh file, which is available inside deploy and observability, guys. Okay. This is the install.sh file. Inside this file you can find all these commands, guys. So these commands is going to set up observability stack, but anyhow we are not going to install this, because in phase 4 we installed everything, guys. Okay. So now in step 2 we need to confirm this whether this is installed or not on observability stack. So let me copy this command and let me paste it here. It is going to display all the pods on observability namespace. So earlier I shown this namespace, right? So here you can see these are all the pods related to observability, like Prometheus, Grafana, and Alert Manager. And these are the Loki related pods, and this is the Open Telemetry and Tempo related pods case. Okay. So everything is running from last 63 minutes. And if you want to check PVC, you can directly check this case. Okay. So these are the PVCs case. Okay. So now let me come here. So basically in step 3, every one of our service is already configured to send its traces to the open telemetry collector, and that setting is backed into our Helm chat case. Okay. So nothing to turn on, and the moment the service starts, they will already report on it, guys. Okay. So now let me show you this in banking Helm chat. So you can directly copy this. Okay. So this is the main thing. Copy this and let me open the Helm chart, guys. Okay. So this is the other repository. Okay. Now let me go to deploy and Helm and banking application and values.ml. Inside this, we need to check that, guys. Okay. And here you can see hotel, it's already enabled, and this is the endpoint, guys. Okay. So here you can see this is the endpoint. So it's not necessary to do any modifications here, guys. Okay. So because I already updated this, but to remind, I was just showing you this, guys. Okay. So if it's not updated, you need to update this in helm values.ml file, and just you need to restart the deployment, guys. Okay. Or else when you update this endpoint, right, automatically GitHub Actions pipeline will trigger and it will update Helm values, meaning image tags on Helm values.ml file. And next Argo CD will come to picture and it will automatically deploy this updated Helm chart to the Kubernetes cluster, guys. Okay. Now, this is step 4. So in step 4, we are going to verify 3 signals are following, like metrics landing in Prometheus, logs landing in Loki, and traces landing in Tempo. And this is the proof that our whole observability pipeline is working end to end, guys. Okay. So now let me copy this and let me come here and let me paste it here. Okay. So it's working properly. So now let me come here, guys. Okay. So now in step 5, let me come down. Okay, right. So in step 5, we will access the dashboards on our domain. So we will open the tool on our domain, like Prometheus, Grafana, and Alert Manager, each on its own path. In Grafana, I will show the per service dashboard, and I will kick any service from drop down, and instantly I'm going to show you all the pods, request rate, response time, CPU and memory, and its live Loki logs all in one view, guys. Okay. And in Prometheus, I can run all the queries against the raw metrics, and the alert manager is where any alerts would show up, guys. Okay. So now let me apply these 3 ingress routes, guys. Okay. For Prometheus, Grafana, and alert manager, guys. Okay. So now here you can see this is the ingress route for Grafana. And when I hit vjgit3.in/grafana, behind the hood, this ingress route is going to route traffic to this cube Prometheus track Grafana service, guys. Okay. And here you can see, let me cancel this. kubectl get okay, let me do one thing. kubectl get ns kubectl get service hyphen n observability. Okay. Now inside this service, it is going to route to this service case 𝐸-Prometheus tag Grafana. Let me show you that. 𝐸-Prometheus tag Grafana. Okay, so this is the service, and this service is running on port 80, guys. Okay, it is going to route this ingress route to this service to access Grafana. Similarly, this ingress is route is for Prometheus. So here you can see 𝐸-Prometheus tag Prometheus, and here you can see 𝐸-Prometheus tag Prometheus. So this is the service. So this ingress route is going to route traffic to this Prometheus service when we hit vjgit3.in/Prometheus. Okay, and it's running on port 9090, and here you can see 9090. Okay, now finally this ingress route is for alert manager, guys. Okay, and here you can see it is going to route to alert 𝐸-Prometheus tag alert manager, and here you can see 𝐸-Prometheus tag alert manager, guys. Okay, and it's running on port 9093 and 9093. Okay, and name is alert manager http, and when I hit vjgit3.in/alert manager, it will route to this. But before applying this, you need to update this host names, case. Okay, manually you need to update this three host names with your domain, and you need to update this case. Okay, in my case I just directly provided my domain names. Let me copy this, let me paste it here, guys. Okay, and next let me come down. We need to verify these three. Let me copy this, and Grafana it's created, Prometheus alert manager it's created three, guys. Okay, and in observability namespace we are going to get all the three ingress routes. So here you can see alert manager http route, Grafana http route, Prometheus http route, all the three has been created successfully. So if you want to describe anyone, for example Grafana, you can directly run like this case. Okay, kubectl hyphen n observability describe ingress route and name of the ingress route. Okay, and here you can see name is Grafana ingress route, namespace it's deployed on observability, labels and annotations we haven't provided anything, and this is the API version, and kind is ingress route. So this is the metadata, it's deployed, meaning it's created on this time, generation is 1, resource version is this, and this is the UID. And when we hit vjgit3.in/grafana, behind the hood it will route to this 𝐸-Prometheus tag Grafana service case. Okay, in the background. Okay, so similarly if you want to describe for alert manager Prometheus, simply change this namespace, that's it. Okay, kubectl hyphen n observability. So hyphen n observability is nothing but this is the namespace, and we are going to describe this ingress route and name of the ingress route. We need to provide alert manager and Prometheus if you want to see, guys. Okay, now let me come here. Now let's try to access this Prometheus, Grafana and alert manager on UI. Let me copy this. Let me open Grafana, or else let me try to open in incognito window. Let me try like this. Okay, I think it is going to take some time. In the meantime, let me add Prometheus also. Prometheus. Similarly, let me add alert manager. Okay. So it is going to take some time, guys. Okay, so let's wait for some time. Let me do curl on this locally first. Okay, for Prometheus we need to see healthy, and for alert manager we need to see okay, and for Grafana we need to see database as okay and JSON data, guys. Okay, but here it is not showing anything, right? Meaning we need to wait for some time, guys. Okay, let me come here and let me refresh this, I don't know, DNS is taking so much of time today. But while I was testing this application, it has completed very fast, guys. Okay. Sometimes it will complete in less than 5 minutes. Sometimes it will take more than hours also, guys. Okay, for DNS. And DNS part that will be not in our hands. Let me come here. So let's wait for some time. So I will be back once these are available. So here you can see I can able to access Grafana, Prometheus and Alert Manager after 5 minutes, guys. Okay, I just waited for 5 minutes. After that, automatically it has started working. So now let me log into this Grafana. So for Grafana, username and password is admin for the very first time. So username is admin and password is also admin. And let me select here login, and it will ask us to reset the password, guys. Okay, so let's reset the password. It is showing login. So let's wait for some time. Let me refresh this Prometheus. Also, let me refresh this alert manager. Okay, something is wrong again. Again, this is unreachable. Okay, now again it is reachable. And let me reload this. Again, this is reachable. Login failed. Let me refresh this page, guys. Okay. Now again, let me provide admin, admin, login. Okay. So new password is okay. Vijay at the rate 123. Vijay at the rate 123. Okay. So this is the new password for Grafana I'm going to provide. And password has been updated successfully, guys. Okay. So now let me come here. Okay, first let me explain you about these dashboards or else, guys. Okay, first let me explain you about these Prometheus dashboards. So let me open this Prometheus. Previously, as I said, for every service we have individual dashboard, right? So you can find individual dashboards inside this banking service details per service dashboard, or else if you want to see only single dashboard for banking platform, you can directly open this. Okay, and here you can see for this is the single dashboard for all the services, guys. Okay, now per service dashboard, you need to open this banking service details per service. And here you can see these are the account service dashboard. So when I drop down these services, so account service, admin, analytics, API gateway, or audit service, auth, beneficiary, card service, currency exchange service, customer service, document, email, EMI, fixed deposit. Like this, we have 30 services, guys. Okay, so these are all the backend services. And if you want to see in detailed information for every service in Grafana, you can directly check here, guys. Okay, and here you can see currently it is for account service, and for account service it is running single pod, and this is the request rate, and this is the P95 latency, and this is the error rate, and this is the request rate by status, and this is the latency like P50, P95, P99, and this is the CPU usage per pod, and this is the memory usage per pod, case. Okay, and fail to fetch. Okay, something is wrong. Let me refresh this page again. I think connection is lost, guys. Okay, okay, again we lost the connection. Let me try to access in incognito window. Okay, I was unable to access this. Let me open this documentation once again, and let me run these commands. So here you can see after 5 minutes I can able to access Prometheus, Grafana, Alert Manager, ArgoCD, and our main application, which is banking application and everything. Let me try to access alert manager also. Alert manager, okay. So everything we can able to access. So now let me show you all the dashboards. So you can directly jump on to dashboards. And this is the per service dashboard. You need to open this. So previously here you can see account service. For account service, we have single pod running. So this is the request rate, P95 latency. This is the error. And this is the request rate by status, and this is the latency like P50, P95, P99, and this is the CPU usage per pod, and this is the memory usage per pod, and these are the live Loki logs, guys. You can see everything in live in Loki. Similarly, for every service we have individual dashboard. So here you can see we have multiple services like admin service, analytics service, API gateway, audit service, auth service, beneficiary service, card service, currency exchange service, customer service, document service, email service, EMI service. Like this, we have multiple services case. Okay. For example, if you want to see reports service details, so you can see for report service we have single pod running. And if you want to check this, so this is the reports service, right? So let me show you this kubectl get pods hyphen n banking and grep reports. Okay, it is going to show the pod of report service. So here we need to see only single pod base. Okay, so let me show you that. And here you can see for report service we have only single pod, and here you can see it is showing single pod. Okay, so similarly like this we have multiple services dashboards, guys. Okay, and this is the loan service. We can see everything. For loan service we have only single pod, guys. Okay, now this is about the Grafana dashboards. So now let me open this documentation and let me come down. Okay, okay, so here you can see you can directly skip this step 6 as well as step 7, because step 7 metric service is already installed using ArgoCD. Okay, let me show you that. So here you can see this is the ArgoCD, and here you can see metric server is already deployed using ArgoCD application. And if you want to check that, you can directly come here and kubectl get app hyphen n ArgoCD. Okay, and grep metrics. It is going to show us the application of metric server, and here you can see metric server is already installed. Now if you want to cross check this, you can directly do kubectl get pods get HPA, guys. Okay, so if HPA is working, metric server will be installed, this. Okay, because all the metrics will collect from this metric server itself, guys. Okay, for the pods. So let me paste it here. We need to see all the horizontal pod autoscales for all the services case. Okay, and here you can see for 30 service we have all the horizontal pod autoscales case. Okay, so this is working fine. So now let me open Prometheus. Before opening Prometheus, here you can see you can find all the Prometheus queries inside this observability.md file. Okay, so if you want to see all the targets, you can directly run command up, and if you want to see all the banking targets, you can directly run this command up namespace equal to banking. Okay, so now let me show you all the targets. Let me open Prometheus and up and execute. Okay, it is going to show us all the targets, guys. Okay, I think again we got DNS issue, so that is the reason why again this is loading. Let me refresh Grafana. Okay, so I think again we lost connection. Let me refresh Prometheus. Let me refresh alert manager, guys. Okay, again we lost this connection. Okay, we can able to access alert manager, but again we cannot access this Grafana and Prometheus. Okay, now Grafana has loaded successfully, guys. Okay, so sometimes it was happening like this, but I don't know, while I was testing this application it has worked well. This issue is from DNS side, guys. Okay, this is not from our side. Now let me open Prometheus, and here you can see all the targets are up, guys. Okay, now let me quickly run this command, which is all banking targets. So if you want to see all the banking targets, you can directly run this Prometheus query. And let me select here execute. And here you can see profile service, fraud service, ledger service, document service, auth service, support service, fixed deposit service, investment service, search service, front end, report service. You can see all the services guys. And here you can see one, meaning everything is up. Now let me open this documentation. And if you want to see total HTTP request per service, you can directly copy this command and you can directly paste it here and execute. And again, I think we lost connection. Let me refresh this page. Okay, so meanwhile let me open this documentation. Okay, so if you want to see total HTTP request per service, you can directly run this query. And if you want to see per route details for every service, you can directly run this query guys. But inside this you need to replace the service name. This is, it will show for transaction service. Similarly, if you want to see for other service, you need to update this service name. And if you want to see request rate per service, similarly you need to run this command. And if you want to see error percentage per service, you can directly run this command. And if you want to see P95 latency per service, you need to run this command. Okay, and if you want to see top 5 busiest endpoints, you can directly run this command. So it is going to show us a top 5 busiest endpoints. Let me refresh this page once again. Okay, so it's not loading. So there is some issue with DNS guys. Okay, so I will do one thing. I will try after 10 hours guys. Okay, because right now time is around 12 a.m. Mm, still time now. Okay, so here you can see right now it's 12:21 a.m. So I will wait till morning 8 to 9 a.m. and I will continue this case. Okay, because DNS is not working properly, right? So this is the big problem. I will try after 10 hours and I will show you everything. Meanwhile, if you want, you can directly run all these queries guys. Okay, if you want to see how many pods are restarted, you can directly see the count. And if you want to see deployment available replicas, you can directly run this command. And CPU usage per pod, you can directly run this query. Memory usage per pod, you can directly run this query. You can directly run this queries guys. Okay, I written nearly 16 queries guys. Okay, all the queries are working guys. Okay, so if you want, I can show you that tomorrow. But now let's skip this case. Okay, let me refresh this, or else I will do one thing. Let me open this documentation. From tomorrow I will directly continue from 07 https -tls setup. And finally at last I will explain you these Prometheus queries, Grafana dashboards. Anyhow, I already showed you Grafana dashboards, right? I need to run some Prometheus queries. So in https, while I was explaining this HTTPS setup, right, I will run some Prometheus queries guys. Okay, that will be better. So I will be back after 10 hours guys. Okay, so here you can see after 15 hours I can able to access everything: Grafana, Alert Manager, ArgoCD, Prometheus, and the banking application. Okay, so let's run these Prometheus queries after setting up HTTPS connection guys. Okay, so now let me directly jump on to phase 7. So in phase 7, we are going to secure everything with HTTPS. So HTTPS encrypts all the traffic between the user and our server. So no one in between can read or tamper with it guys. Okay. And to prove our site is genuine, we need to create a certificate issued by a trusted authority. Now certificates normally cost money, right? And expiry, but we use Let's Encrypt, which issues real browser trusted certificates for free. And we automate the whole thing with a tool called Cert Manager guys. Okay, so Cert Manager handles everything automatically. It requests a certificate and Let's Encrypt does a quick challenge to prove we actually own the domain or not. It asks our server to serve a special token at our address and confirms it, and then issue the certificate case. Okay. And when the certificate nears expiry, set manager renews it automatically roughly for every 75 days. So we never have to think about it again, guys. Okay. Just like the observability stack, set manager and the certificate issuer were already installed by ArgoCD in phase 4. So most of the phase is already wired up, guys. Okay. So we just need to complete the secure setup, guys. Okay. And by the end of this phase, our entire platform and all the dashboards will be served over HTTPS case, okay, with a genuine auto renewed certificate case. Okay, so now let's finish this HTTPS setup. So now let me run this first. So here you need to update your host name as well as email address. So email here you can provide any of the dummy email also, guys. Okay, that is not a problem. So let me copy this. Okay, it got closed. Let me do one thing. Let me open Ubuntu 22.04 and let me close this. CD AWS CKS PD, and this is my repository banking application. Okay, now let me do kubectl get ns kubectl get pods hyphen n banking. Let me check all the pods in banking namespace whether these are running or not. And here you can see all the pods are in running state, guys. Okay, so now here you can see I'm going to export my host name, which is vijay.in. In this case you need to update your host name, guys. Okay, and here you just provide any dummy email, or else you can provide your email also, guys. That is not a problem. And let me hit enter. Okay, it's exported successfully. So now let me open this documentation and let me directly jump on to step 1. Okay, so basically in step 1 and step 2, we will start by confirming set manager is running or not, and that our let's encrypt cluster issuer is ready or not. Okay, and these are the two pieces that will fetch and manage our certificates, and ArgoCD has already deployed these two ways. Okay, so now let me check this. If you want to install manually using Helm, so you can directly run this command. Please. Okay, first let me show you the ArgoCD application. Let me directly come here and let me paste it here. It is going to show us the set manager ArgoCD application, and here you can see set manager, it's synced and healthy. And if you want to check this in ArgoCD UI, so here you can see this is the set manager, guys. Okay, and inside this you can see all the pods, deployment services and everything. Okay, I think again we lost the connection. Okay, it's loading again. I think we lost the connection, so that is the reason why it's loading. Let me show in the uh, CLI. Let me cancel this. Now kubectl get ns, and we have namespace called set manager. Inside this it's deployed, guys. Okay, last 14 hours ago it's got deployed. Now let me copy this kubectl get pods hyphen n set manager. It is going to show you all the pods for set manager. So here you can see two set manager pods are installed. CA injector pod is installed. Webhook also it's installed, guys. Okay, now let me show you all the resources inside this set manager namespace. Okay, get all hyphen and set manager. It is going to show us all the pods, deployment services, replica sets, config maps, and everything inside set manager namespace. So here you can see we have two pods for set manager, and this is the CA injector, and this is the webhook, and this is the set manager service, and this is the set manager webhook. So this is the set manager deployment. This is the CA injector deployment. This is the webhook deployment. Guys. Okay. Similarly, these are the three replica set. This is the set manager replica set, CA injector replica set, webhook replica set. Guys. Okay. So now let me open the documentation. Okay, so here you can see it's loaded successfully. Inside set manager, these are the services. So these two are the services, set manager and set manager webhook. So this is the service account. Okay, you can see all the resources, guys. Okay, like this already have shown you in the CLI, right? So these are all the resources it's running. Okay, so now let me come out from this. Okay, these are all the applications. Now let me open this documentation and let me come down. Okay, so we already checked this just now, right? Now, in step 2, let me show you the cluster issuer. So cluster issuer, we need to see ready status as true, guys. Okay. So last night it's already created by using ArgoCD itself, it will be true. Okay, so here you can see it's true guys. Okay, 14 hours ago it's already created. So now let me open the documentation and let me directly jump on to step 3. So basically in step 3, the in set manager the app is already set for HTTPS because our Helm chat already has TLS turned on. Set manager automatically requests a certificate for our domain the moment the app is deployed and DNS resolved. So the main app gets the padlock with essential no manual work case. Okay, and it's all driven from Git. So I'm going to skip this because this is already done. So if you want to check this, you can directly check inside this Helm chat, deploy Helm banking application and values.ml file guys. Okay. So let me check for this TLS. Okay. So here we need to keep TLS as true. Okay. So here you can see true. Now let me open GitHub in a new tab, GitHub login. Okay. And here let me open banking application repository. And here deploy and Helm banking platform values.ml and search for TLS. Okay, and here you can see TLS, it is showing true. Okay, now if it is showing false means you need to change to true and you need to retrigger this pipeline guys. It is not necessary to manually retrigger this pipeline. So when you modify to true, right, automatically pipeline will trigger guys. Okay, so now let me open this documentation and let me check this. So it is going to show us the certificate. So here you can see banking TLS, it's already created guys. Okay, let me cancel this, and this is not necessary to run, and if you want to run you can run this case. Okay, and here you can see it is showing these details. Now let me come down, and if you want to check HTTPS connection you can directly run these commands. Okay, so just it is a smoke test guys. Okay, we need to see status code as 200. So if it is showing 200 means HTTPS is working fine guys. Okay, so I was facing lot of issues with the DNS, so that is the reason why it's not working properly. So let's wait for some time. Okay, so now in step 4 we will serve all the dashboards under HTTPS like Grafana, Prometheus and Alert Manager to serve themselves securely under HTTPS by updating their settings to use the secure address case. Okay, and a quick commit and ArgoCD applies it case. Okay, but let me do one thing. Let me check this first inside this deploy observability values and Prometheus stack. Okay, let me come here, deploy and observability, right? Let me check it once again. Deploy observability values. Okay, observability values, and here Prometheus stack. Okay, so inside this let me search for root URL. Okay, I think it is not necessary to search. Let me open this, and here you can see external URLs. It is showing https vijayguruthuri.in/alert manager, and external URL it is showing https vijayguruthuri.in/prometheus, and root URL it is showing https vijayguruthuri.in/grafana guys. Okay, in this file you need to update with your domain names. Don't forget this case. Okay, so you need to come in step 4, you need to come to this directory and you need to open this file and you need to update your domain names case. Okay, and after that try to apply this. Okay, so now let me save this, let me come out from this. Okay, and let me open this and let me directly jump on to step 5. Now in step 5 we will create the secure HTTPS route for ArgoCD, and each dashboard will be reusing the same certificate to access via HTTPS from our domain guys. Okay, so now let me copy this 5A and let me paste it here. Next let me come here, and to cross check this let me copy these two commands. So let's wait for some time. Okay, it's created successfully, and here you can see both the secrets has been created successfully. One secret we created under ArgoCD and one secret we created under observability, guys. Okay. So now let me open this documentation. Now we need to create ingress route for ArgoCD using this created secret, guys. Okay. Banking TLS. Okay. So we are going to associate this TLS set with this ingress route, guys. That's it. Okay. Now let me copy this. Let me paste it here. It is going to just configure, guys. Okay. It is not going to recreate. It will just upgrade that. Now let me check this. Okay, here you can see it's configured successfully, and here it will show 14 hours ago. Okay, 15 hours ago it is showing. That's fine. Now we need to run this command. It needs to show web secure equal to banking TLS, meaning it needs to show our banking TLS secret, guys. Okay, and here you can see web secure is banking TLS. It's completed successfully. So similarly, next we need to update for Prometheus, Grafana, Alert Manager, Ingress routes. So simply we are going to upgrade these three ingress routes, guys, with our TLS set. Okay. So whenever any user is trying to access with https colon slash slash and vijay.in slash grafana, it will route to https, guys. Okay, using this TLS. Similarly for Prometheus and similarly for Alert Manager. Okay. So let me quickly apply these three. Okay. So it's updating. Okay. So all the three has been created successfully. Now let me come down and let me check the three ingress routes in the observability namespace. And here you can see alert manager it's created, Grafana it's created, Prometheus it's created. Now, if you want to see web secure banking TLS for all the three HTTPS routes, we can directly run this query. Okay. For Grafana, here you can see web secure banking TLS, for Prometheus banking TLS, and for alert manager it is showing banking TLS case. Okay. So meaning it's updated successfully. So now we are going to delete old HTTP routes, meaning it is going to serve to HTTP, right? We are going to delete that. Okay. All the three has been deleted. So now let me verify all the five URLs using HTTPS. Okay. So here you can see for our application, it is showing 200, meaning HTTPS is working, and for ArgoCD it's working, and it needs to update for Prometheus, Grafana, and Alert Manager, guys. Okay. So we need to wait for some time. So once after everything is completed, we need to complete this step 7. So basically in step 7, we will run one rule that anyone who visits the plain HTTP version will be automatically redirected to HTTPS, guys. Okay. So no one can accidentally use this insecure version, and HTTPS is enforced everywhere, guys. Okay. So that is the reason why we need to upgrade this. In the meantime, let me do one thing. Let me cancel this and let me copy this and let me upgrade this Helm chart with HTTPS connection, guys. Okay. So it will take around 1 or 2 minutes. Once after upgrading, we will send request to HTTP. Automatically, it will redirect to HTTPS, guys. Okay. I will show you that. So let's wait for some time. So here you can see it's deployed successfully. Now, if you want to check this, you can directly run this command helm ls python and Traefik. We need to see revision as 2, guys, now. Okay. So here you can see revision is 2, and here you can see revision is 2. Okay. It's deployed. And if you want to verify this redirection, you can directly run these commands. Okay. So I think there is a small issue with again HTTPS. Okay. So let's wait for some time. Okay. So here you can see after 5 minutes it started working, guys. Okay. HTTPS is also working fine. So let me close these all tabs and let me reopen it once again. So here you can see https colon slash slash vijay.in. So here you can see connection is secure, guys. Okay. And certificate is valid. So this is the certificate. So similarly, let me try to access for ArgoCD, ArgoCD and slash. Okay. So here you can see we can successfully able to access ArgoCD using this HTTPS connection. Now let me open another one. HTTPS colon slash slash vijay.in slash grafana. And here you can say I can able to access Grafana. https://vijay3.in/prometheus. And here you can see Prometheus is also opening successfully. https://vijay3.in/alert manager. And here you can see alert manager also opened successfully, guys. Okay. So now let me log into this ArgoCD. Let me cancel this. Okay. Now let me directly jump onto ArgoCD and let me provide these details. It is going to provide username and password. So username is admin and this is the password. Okay. Let me copy this password and let me come on to an incognito window, and username is admin and password is this, and sign in. Okay. So here you can see, we can see all the applications. So now let me log into Grafana using my existing credentials. So username is admin, password is Vijay@123 and login. And here you can see it successfully connected to Grafana, guys. Okay. Now let me show you all the dashboards, and here you can see you need to open this banking service details per service. Okay. And here it is going to show you per service dashboard. So this is the account service dashboard and this is the analytics service dashboard. So here you can see live loki logs also, guys. Okay. And currently we are accessing with https connection, if you observe, guys. Okay. Now let me open other service. Let me open this beneficiary service, and here you can see all the running pods, request rate, P95 latency, error rate, request rate by status, latency like P50, P95, P99, CPU usage per pods, memory working set per pods. You can see everything, guys. Okay. Also you can see live logs, live loki logs, guys. Okay. Now let me open other service. Let me open email service. And here you can see this is the email service details. So for email service, it has only running one pod. Okay. So you can check everything, guys. Okay. So if you want to confirm how many pods are running, you can directly come here and kubectl get pods -n banking and grep, and let me check the service name. It's email service, right? Let me provide only email. Okay. Now it is going to show us that email service pod, and here you can see this is the email service pod, guys. Okay. Now let's do one thing. Let's try to connect to this banking application. So my existing details are demo@gmail.com, I guess, and password is demo@123 and sign in and invalid credentials. Okay, so let me try to create new one. So here you need to select create one and full name. Let me provide gituri@gmail.com. Sorry, it's full name, right? Let me copy this and let me remove up to Gituri, and email is gituri@gmail.com. Gituri, okay, Gituri@123. Create account, okay. So here you can see account has been created successfully for my user. Okay, you can create multiple accounts, guys. Okay, and if you want to check that, you can directly open this Postgres guide. Okay, so you can run all these queries, guys. Okay, but in this video I'm not going to run all these queries. Now you need to run this command. Let me come down. This is for auth users. Okay, so this is the command to check every registered user. So just now we registered Gidturi user, right? So let me show you that. And here you can see right now we have two users. One is gituri@gmail.com. So we created just now, and this is the demo user, guys. Okay. And now if you want to count total accounts, you can directly run this query. It is going to show us the total accounts. And here you can see total accounts are 2. And now if you want to find one user by email, you can directly run this query, something like here you need to provide your email, guys. Okay. And now these are the account service credential queries. If you want to see all the accounts, you can directly run this query. It is going to show us all the accounts, guys. Okay. And here you can see we have two accounts. So this is the account number, these are the account IDs, so these are the customer IDs, and this is the type, and this is the currency, and this is the status, guys. Okay. Now for ledger service, you can directly run these queries. And this is for transactions. If you want to see every transaction, you can directly run this query. So I tested all the queries, guys. It's working fine. So here you can see yesterday we just ran one transaction, right? So this is the output, guys. Okay. Now, so now if you want to see outbox events, you can directly run these queries. Okay. And if you want to see notifications dispatched, you can directly run this query. Okay. Let me copy this once again. So here you can see it is showing this. Okay. So similarly, all the queries will work, but these are the useful dashboard queries. So now let me run this query. And here you can see these are all the services which are available right now. And account plus total money in the ledger. If you want to check that, let me run this query. So here you can see total we have two users. For two users, we have two accounts. One is this case. Okay. Now, if you want to see transactions volume by type, you can directly this query. Okay, so deposit money is one, that is 1,000 rupees case. Okay, so this is how you can refer this documentation case. Okay, now let me run few of the Prometheus queries. So yesterday night we haven't run few of the Prometheus queries, right? So now here you can see if you want to see all the targets are up or not, you can directly run up, and if you want to see all the banking targets, you can directly run this command. Okay, now let me come here and let me open Prometheus and let me select here execute. And again, I think we got DNS problem. Let me refresh. Okay, so here you can see everything is loading. That means again we got this problem. Okay, so I was facing a lot of issue with the DNS case. Okay, but in your case, you will not face any issues, guys. Try to test this entire application. Okay, but you can run all these Prometheus queries. So you can run all these Prometheus queries, guys. Okay, it's available inside observability.md file. Okay. So now let me directly jump on to Velero because HTTPS is already completed just now, right? So finally we can able to access with HTTPS. Again, we lost this DNS connection. Okay. So DNS is not working fine for me. No problem. But now let me directly jump on to Velero. In phase 8, we are going to set up Velero for backup and disaster recovery. Think of Velero as our insurance policy. It backups the cluster to the safe storage so that if disaster strikes, we can restore everything, guys. Okay. So our app is already safe in Git and ECR, but the actual banking data and the database and the Kafka logs lives inside the cluster. So Velero backups up to the secure S3 bucket, and the Velero subs was already installed by ArgoCD in phase 4. We just created AWS storage and take a backup and prove we can restore it, guys. Okay. So now let me directly jump on to step 1. So you can directly skip this everything, and this is step 1. So in step 1, we will create AWS resources with Terraform. So first Velero needs a place to store backups and permissions to write there, right? So we run a small separate Terraform stack that creates two things, an S3 bucket for backups and an IAM role that Velero assumes securely. And this stack is kept separately from our main infrastructure on purposes. So backups are completely optional. We can remove on their own, guys. Okay. So now let me directly come down and we need to run these commands, guys. Okay, so we need to enter into this Terraform and Velero and we need to apply this. Okay, so let me show you this. Let me open this GitHub repository and directly jump on to Terraform. So this is Terraform, and inside this you can find Velero. Okay, so we are going to execute this Terraform scripts, guys. Okay, it is going to create a S3 bucket as well as it is going to create IAM rules, guys. Okay, so now let me create this. Let me copy all this and let me come here. Let me paste it here, guys. Okay, so first it is going to initialize. Next it is going to directly apply, guys. Okay, so it will take around 1 or 2 minutes to install this. So let's wait for some time. So here you can see all the 6 resources has been created successfully. So now if you want to check that the created S3 bucket, you can directly jump on to S3, and here it will create an S3 bucket with name 𝐊𝐿𝐻 guys. Okay, let me show you that. And okay, so here you can see banking 𝐊𝐻 backups guys. Okay, so it's created successfully. So now let me open this documentation. So in step 2, we are going to install a 𝐊𝐻 CLI, but I'm not going to install this case. Okay, I'm going to skip this in my local. So step 3 is install 𝐊𝐻 server. But the 𝐊𝐻 server is already running because ArgoCD already installed the 𝐊𝐻 server in phase 4 itself. So the moment our S3 bucket and IAM role exits, 𝐊𝐻 connects to them and we just need to confirm the backups location shows available. That's 𝐊𝐻 telling us it's successfully authenticated to S3 guys. Okay. But here also I'm going to skip this everything because all this is completed guys. Okay. Now let me come down. And if you want to check this 𝐊𝐻 ports, you can directly run this command. It is going to show us all the ports inside 𝐊𝐻. And let me show you a 𝐊𝐻 application. Let me refresh this. I think there is an issue with the DNS again. Let me come here to the CLI kubectl get app -n ArgoCD. Okay, it is going to show us all the applications, and here you can see 𝐊𝐻 application. Okay, so it's synced and healthy. Now let me do this command kubectl get ns and kubectl get all -n 𝐊𝐻. Okay, it is going to show us all the resources inside this 𝐊𝐻 namespace. So here you can see all the pods are running, and this is the 𝐊𝐻 cluster IP service. So this is the daemon set. See, this is the deployment. This is the replica set guys. Okay, so now let me open this documentation, and if you want to see 𝐊𝐻 backup location, you can directly run this guys. Okay, so here you can see this is the 𝐊𝐻 backup location. So the bucket name is this banking 𝐊𝐻 backups. Okay, so if you want to check this, so here you can see banking 𝐊𝐻 backups. So this is the bucket. In this bucket, it is going to store all the backups guys. Okay, now let me open this documentation and let me directly jump on to step 4. Now in step 4, we will take our first real backup of banking namespace, and we will include the volume data and the actual database contents are captured, not just the Kubernetes objects case. Okay. Then we confirm it completely that the backup files are really loaded in S3 guys. Okay. So now let me copy this and let me paste it here. It is going to take backup for our banking namespace. Okay. So here you can see it is taking backup guys. Okay. So once it's completed, let me run this command. Inside this banking 𝐊𝐻 backups S3 bucket, we are going to check whether this banking manual one backup is available or not guys. Okay, so it is taking entire backup. So backup is also completed guys. Okay, so now let me run this command, and here you can see it's taken this backup guys. Okay, so let me show you in the console itself. Let me directly jump on to S3 and let me open this bucket banking 𝐊𝐻 backups, and let me jump on to backups manual banking manual backup one. So here you can see it has taken entire backups case. Okay, volume snapshots, banking manual one, 𝐊𝐻 backup.json. Okay, so pod volume backups. Okay, so it has taken every backup from banking namespace case. Okay, so this is how 𝐊𝐻 is going to work. So now let me open this documentation once again, and let me directly jump on to step 5. So let me directly come down. Step 5 is schedule daily backups, and this is optional because this is not a real production environment, right? We set up a schedule so 𝐊𝐻 backups automatically every day and keeps the last 7 days backups case. Okay. So now let me apply this command also because this is optional. But anyhow, let me apply this. We are going to schedule backup. Okay, so it's created successfully. Now let me commit this. Okay, no such file or directory. Let me come out from this. Okay, no such file or directory. Where is this? It's deploy failure. Okay. But anyhow, we can skip this case. Okay. So now let me come down, and finally step 6 is disaster recovery test. And if you want to test, you can run these commands case. Okay. But I'm not going to run these commands. But if you want to test, you can directly run these commands case. Okay. So this is about this project. So entire project is completed successfully, guys. But let me open this and let me finally refresh this page. So again, okay, again this is working, as you can see. So sometimes this is working, sometimes this is not working. Let me open Prometheus and let me open Grafana and let me open Alert Manager. Everything is working, guys, now. Okay. So here you can see, if you want to see per service dashboards, you can directly open this banking service details. And here you can see for every service we have multiple dashboards, guys. Okay. And this is the ArgoCD UI. So we deployed everything using a GitOps approach, right? So these are all the applications, guys. Okay. So these are all the applications. Everything is deployed and running successfully. And this is our main application. Okay. So this is Prometheus. And if you want to run some Prometheus queries, so all the Prometheus queries are available inside this observability.md file. Okay. Let me come down. Okay, so here you can see these are all the Prometheus queries, guys. Okay, so you can run any query, guys. Okay, so let me run any single query. So if you want to see 5 busiest endpoints, you can directly run this query. Okay, let me remove this and let me paste it here and let me execute this. Okay, so here you can see these are the 5 busiest endpoints, guys. One is report service, search service, document service, investment service, auth service, guys. Okay, so these are the 5 busiest endpoints. And let me come here, and if you want to see total pod restarts, you can directly run this query in Prometheus. So all the queries are working, as okay, I tested everything. So here you can see it's restarted 2 times, 3 times, 3 times, 2 times. Okay, so here you can see everything in detail. Okay, now let me come here and let me show you all the banking application targets. Let me paste it here and execute. And here you can see these are all the banking targets case: profile service, fraud service, ledger service, document service, author service, support service, fixed deposit service. These are all the targets case. Okay. And yes, that's it about this project. And this is our main UI, banking UI. Okay. So now let's try to destroy this entire application. So after completing this application, don't forget to delete, guys. Okay, because for every hour it is going to cost around 1 USD, guys. Okay, to create this project, I wasted nearly 24 USD, guys. Okay, so be very safe after completing your project. Try to destroy all the AWS resources, guys. Okay, not only on AWS. If you are doing this on GCP or if you are doing this on Azure, try to delete all the resources, guys. Okay, because these resources are not free. These are all paid resources, guys. Okay, because we are running a EKS cluster with the 4 nodes, guys. Okay, so this is not a free. This is paid. So here you can see it's running from last 17 hours, guys. Okay, so it will cost me around 20 USD to complete this project, guys, because I was running everything from last 17 hours, guys. Okay, so now I'm going to destroy all these resources. Let me directly jump on to Terraform. Okay, Terraform, environments, and ls, and let me jump on to dev. Okay, so here we have three. One is dev, q, and prod. So we went to dev. Let me do ls, and let me run Terraform state list. It is going to show us all the created resources. So we created everything using Terraform, guys. Okay, so here you can see we created everything end to end using Terraform. So now I'm going to delete all these resources using single command: Terraform destroy hyphen hyphen auto hyphen h2. Okay, so now slowly it will destroy all the AWS resources like VPC, public and private subnets, route tables, internet gateway, NAT gateway, EKS clusters, IAM roles, S3 buckets, ECR repositories, everything it will delete, guys. Okay, once after deleting this, you need to directly jump onto IAM. Where is this IAM? Let me open IAM in a new tab. Okay, so you need to jump onto your user. So in my case, my user is Vijay Girturi, and in security credentials, so these are my access keys, case. Okay, so I will delete this both access keys. parallelly you need to delete your GitHub personal access token also, guys. Okay, that will be very secure. Okay, so currently this banking application EKS repository is a private repository. So while I was releasing this project, right, at that point of time I will make this repository as a public repository, guys. Okay, so let me come here. So it will take around 15 to 20 minutes to destroy all these resources, guys. Okay, so and yes, that's it for today's video. And if you like my video, please do like, share and subscribe to my YouTube channel, and see you in the next video, and bye.